ULCCS-MatterLab TechTalk series, consisting of technical conferences, seminars, webinars, and workshops associating with industry, academic, and research professionals. Uralunga Labor Contract Cooperative Society, ULCCS Limited, is a 98-year-old cooperative and one of the world's largest labor contract cooperative society. The United Nations recognizes ULCCS for best practice in labor and project management. Our focused areas are infrastructure,
the most decisive virtue that built the Uralunga Labor Contract Cooperative Society into one of Asia's largest workers' cooperatives is courage. Because without courage, you cannot practice any other virtue consistently. Those virtues imbibed by our 14th founding Guru Vakpadananda. They established the Ural Mutual Aid and Cooperative Society as a solution to the unjust practices against the courage that is derived from our values of cooperative culture, collective ownership, and democratic work culture is now connecting people with smoother roads towards development. Trustworthiness that we enjoy reflects our courage for complete self-reliance with zero subcontracts. The ULCCS has nurtured our own human and material resources for our projects that bridges the most crucial of gaps for the people. Imposing structures of social and cultural significance that we have built stand tall on the foundations of our courage to adhere to the highest quality standards. It takes courage to stick to the path of commitment for on-time delivery, which is in themselves to the world. Our relentless pursuit of new horizons has helped us take our core values to different sectors, empowering them with the courage that we had imbibed over a century. When it comes to making lives better for the less privileged, there are no easy answers, but there are simple answers. We must have the courage to do what we know is morally right. Our courage inspires people from all sections of the society to stretch their limits, express their power, and fulfill their potential. Courage is what it takes to choose quality over everything else, to turn quality from a mere act to a habit that it rightfully is. We see courage as a muscle, strengthened only by use, the one we use to modernize traditional businesses, realize career dreams of over 10,000 youngsters, and improve the lives of over 1,200 million people. For us, courage is the most important virtue.
Thank you. In pursuit of the vision to create sustainable societies and benchmark infrastructure contributing to the nation's socio-economic development, ULCCS has recently set up one of the largest material testing lab in South India, the Matter Material Testing and Research Laboratory Private Limited, MatterLab, at Kozhikode, Kerala. The lab has advanced facilities to undertake a wide range of material testing in construction, geotechnical, metallurgy, chemistry, environmental, and microbiology. A short video about MatterLab will be playing on the screen now. Onto the screen, please.
We are MatterLab. A wholly independent professional and technical services provider for everything concerned with quality and performance of materials and products. What we offer is a bold promise of certainty to those sectors where failure in service is simply not an option. Our exceptional testing facilities are a testament to our promise. Services offered by MatterLab cover a plethora of sectors ranging from buildings and facilities to roads and airports, infrastructure to rail and light rail. Our parent company has a very long history and heritage that spans over about 95 years, which we are justifiably proud. We are an amalgamation of its traditional values of top-notch quality, transparency, and engineering leadership. MatterLab, where quality matters.
Thank you. To begin with the inauguration program, I would like to invite our Honorable Chairman, ULCCS Private Limited, Shri Paleri Rameshan sir, for the welcome address. Sir, please.
അതിൻ്റെ ജന്മശതാബ്ദി വർഷത്തിലേക്ക് പദമുന്നയാണ്. ഈ ഘട്ടത്തിൽ പുതിയ സാങ്കേതികവിദ്യകൾ ആർജിക്കുവാനും പങ്കുവെക്കുവാനുമുള്ള ഒരു പുതിയ സംരംഭത്തിന് കൂടി സൊസൈറ്റി തുടക്കം കുറിക്കുകയാണ്. സൊസൈറ്റിയുടെ പുതിയ സ്ഥാപനമായ MatterLabുമായി ചേർന്ന് സംഘടിപ്പിക്കുന്ന സാങ്കേതിക വിദ്യാ പ്രഭാഷണ പരമ്പരയാണ് പുതിയ പരിപാടി. ഊരാളുങ്കൽ സൊസൈറ്റി തന്നെ ഒരു ഇന്നൊവേഷനായിരുന്നു. തൊഴിലാളികളുടെ സഹകരണ സംഘം എന്ന ആശയം കേരളത്തിൽ ഒരുപക്ഷെ രാജ്യത്ത് തന്നെയോ ഇല്ലാതിരുന്ന കാലത്താണ് ജനങ്ങൾക്ക് തൊഴിലുണ്ടാക്കുവാൻ തൊഴിൽ കരാർ സംഘം എന്ന ആശയം ഗുരു ബാഗ്ബാനന്ദൻ്റെയും അദ്ദേഹം രൂപം നൽകിയ ആത്മവിദ്യാ സംഘത്തിൻ്റെയും ബുദ്ധിയിൽ ഉദിക്കുന്നത്. അന്നു മുതൽ ജനകീയ പ്രശ്നങ്ങൾക്ക് പക്ഷബദലുകൾക്കും ആവിഷ്കരിക്കുന്നതിൽ സൊസൈറ്റി എന്നും ജാഗരൂകരായിരുന്നു. ആ ഉൽപ്പതിഷ്ണത്വമാണ് നിർമ്മാണ രംഗത്ത് ലോകത്ത് എവിടെയും പുതിയ സാങ്കേതികവിദ്യയോ യന്ത്രോപകരണമോ നിർമ്മാണ സങ്കേതമോ വികസിപ്പിച്ചതായി അറിഞ്ഞാൽ എത്രയും വേഗം അത് സ്വായത്തമാക്കാൻ സൊസൈറ്റി എന്നും പ്രചോദിപ്പിക്കുന്നത്. അതിനായി വിദേശങ്ങളിലെ മികച്ച കോപ്പറേറ്റീവ്സ് ശൈലിയിൽ റിസർച്ച് ഡെവലപ്മെൻറ്റ് വിഭാഗം ഉണ്ടാക്കി തന്നെയാണ് ഊരാളുങ്കൽ സൊസൈറ്റിയും ഈ രംഗത്ത് പ്രവർത്തിക്കുന്നത്. സാമൂഹിക ആവശ്യങ്ങൾക്ക് ജനപക്ഷ ബദലുകൾ സൃഷ്ടിക്കുക എന്ന സമീപനം തന്നെയാണ് ആധുനിക വിദ്യാഭ്യാസ മേഖലകൾ വികസിക്കുകയും യുവാക്കൾ ആ രംഗത്ത് പ്രാവീണ്യം നേടുകയും ചെയ്യാൻ തുടങ്ങിയപ്പോൾ അവർക്കുചിതമായ തൊഴിൽ ലഭ്യമാക്കാൻ വൈവിധ്യവൽക്കരണത്തിലേക്കും സൊസൈറ്റിയെ നയിച്ചത്. IT മേഖലയിൽ തൊഴിൽ സൃഷ്ടിക്കാൻ ULCCS പാർക്കും UL ടെക്നോളജി സൊല്യൂഷൻസും ഒക്കെ ആരംഭിക്കുന്നത് അങ്ങനെയാണ്. നമ്മുടെ സാങ്കേതിക വിദ്യാഭ്യാസ സ്ഥാപനങ്ങളിൽ പഠിച്ചിറങ്ങുന്ന തൊഴിൽ നൈപുണ്യം വേണ്ടത്ര ഇല്ല എന്ന തിരിച്ചറിവിൽ നിന്നാണ് സ്കിൽ ഡെവലപ്മെൻറ്റ് രംഗത്ത് സ്കിൽ അക്കാദമിയും DDGKയും പരിശീലന കേന്ദ്രവും ആരംഭിക്കുന്നത്. സംസ്ഥാന സർക്കാർ സ്ഥാപനമായ IIIC ഏറ്റെടുത്ത് നടത്തുന്നതുമൊക്കെ പ്രതിസന്ധി നേരിടുന്ന കരകൗശല കലാകാരന്മാർക്കും മെച്ചപ്പെട്ട തൊഴിലും വരുമാനവും ഉറപ്പിക്കാൻ ടൂറിസത്തിൻ്റെ ആഗോള വിപണിയുടെ സാധ്യതകൾ പ്രയോജനപ്പെടുത്താനുമാണ് ആർട്സ് ആൻഡ് ക്രാഫ്റ്റ് വില്ലുകൾ തുടങ്ങിയത്. മലബാറിനെ IT ഡെസ്റ്റിനേഷൻ ആക്കുവാൻ കൂടിയാണ് ULCCS പാർക്കിന് സമീപം ഒരു മികച്ച റെസിഡൻഷ്യൽ സൗകര്യം ഒരുക്കുവാനും വൺ ആന്തം എന്ന അപ്പാർട്ട്മെൻറ്റ് പദ്ധതിക്ക് രൂപം നൽകിയതും. സൊസൈറ്റി ഏറ്റെടുക്കുന്ന നിർമ്മാണ പ്രവൃത്തികൾ തൊഴിലാളികൾക്ക് തൊഴിൽ ലഭ്യമാക്കുക എന്നതിലുപരി രാഷ്ട്ര നിർമ്മാണ പ്രവർത്തനമാണ് ഊരാളുങ്കൽ സൊസൈറ്റി കാണുന്നത്. അതുകൊണ്ട് തന്നെ വിട്ടുവീഴ്ചയില്ലാത്ത ഗുണനിഷ്ഠ എന്നും സൊസൈറ്റിയുടെ നിർബന്ധമായിരുന്നു. സൊസൈറ്റിയുടെ നിർമ്മാണങ്ങളിൽ മാത്രമല്ല നാട്ടിലെ എല്ലാ നിർമ്മാണങ്ങളിലും ഗുണമേന്മ ഉറപ്പുവരുത്തേണ്ടത് ആവശ്യമാണെന്ന് സൊസൈറ്റി കാണുന്നു. ഇതൊക്കെ പേരിട്ട മാറ്റർ മെറ്റീരിയൽ ടെസ്റ്റിംഗ് ആൻഡ് റിസർച്ച് ലബോറട്ടറി ലിമിറ്റഡ് എന്ന സ്ഥാപനവും ഊരാളുങ്കൽ സൊസൈറ്റിയും ചേർന്നാണ് ഈ TechTalk സീരീസ് സംഘടിപ്പിക്കുന്നത്. നിർമ്മാണ രംഗത്തെ പുതിയ സമ്പ്രദായങ്ങളും സങ്കേതങ്ങളും നമ്മുടെ നാട്ടിൽ പ്രാവർത്തികം ആക്കേണ്ടതുണ്ട്. ഒരുപക്ഷെ പലപ്പോഴും നാം അതിൽ വൈകുന്നതാണ് കാണുന്നത്. രാജ്യത്ത് അവ പരിഷ്കരിക്കുവാനുള്ള ശ്രമങ്ങൾ നടന്നു വരുന്നു എന്നതാണ് മനസ്സിലാക്കുന്നത്. അത് സ്വാഗതാർഹമാണ്. ഈ രീതിയിൽ പ്രാവർത്തികമാകണമെങ്കിൽ സർക്കാരുകളുടെ നിയമചട്ടങ്ങളിലും മാനുവലുകളൊക്കെ മാറ്റം വരുത്തേണ്ടതുണ്ട്. അതോടൊപ്പം തന്നെ അത്തരം വിഷയങ്ങളെല്ലാം സമഗ്രമായ അറിവ് നിർമ്മാണ രംഗത്ത് പ്രവർത്തിക്കുന്ന സാങ്കേതിക വിദഗ്ധർക്ക്, സ്ഥാപനങ്ങൾക്കും ഉദ്യോഗസ്ഥന്മാർക്കുമൊക്കെ അപ്പോൾ ലഭ്യമാക്കുവാൻ കഴിയേണ്ടതുണ്ട്. വിവിധ സ്റ്റേക്ക് ഹോൾഡേഴ്സ് വിഭാഗങ്ങളിലെ ഈ ആശയങ്ങളും ആവശ്യബോധവും എത്തുമ്പോഴേ മാറ്റത്തിനുള്ള സമ്മർദ്ദം ഉയരുകയുള്ളൂ. ഇതെല്ലാം പരിഗണിച്ചാണ് നിർമ്മാണ രംഗത്തെ ആധുനിക ആശയങ്ങളും പ്രവണതകളും പങ്കുവെക്കുന്ന പ്രഭാഷണ പരമ്പര സംഘടിപ്പിക്കണമെന്ന ആശയത്തിലേക്ക് സൊസൈറ്റി എത്തുന്നത്. ആ ആലോചനയുടെ സാക്ഷാത്കാരമാണ് ഇന്നിവിടെ നടക്കുന്നത്. ഈ ചടങ്ങിൽ അധ്യക്ഷം വഹിക്കുന്നത് നമുക്ക് എല്ലാം പരിചിതരും പ്രിയങ്കരനുമായ കേരള ഡിജിറ്റൽ സർവകലാശാല വൈസ് ചാൻസലർ ഡോക്ടർ സജി ഗോപിനാഥൻ സാറാണ്. നമ്മുടെ അഭ്യുദയകക്ഷിയായ അദ്ദേഹം സൊസൈറ്റിയുടെ ഏത് കാര്യത്തിലും കലവറയില്ലാതെ സഹായം നൽകുന്ന ആളാണ്. സാങ്കേതിക വിദ്യാരംഗത്ത് സംസ്ഥാനത്ത് തന്നെ ഏറ്റവും മികച്ച പ്രതിഭകളിൽ ഒരാളായ അദ്ദേഹം ഡിജിറ്റൽ സർവകലാശാല വൈസ് ചാൻസലർ എന്ന നിലയിൽ സ്തുത്യർഹമായ പ്രവർത്തനം ആണ് നടത്തിവരുന്നത്. ഈ പ്രഭാഷണ പരമ്പരയുടെ പ്രാധാന്യത്തെയും അതിന് പിന്നിലെ കാഴ്ചപ്പാടിനെയും ഒക്കെ പറ്റി സൊസൈറ്റിയുടെ ഭാഗത്ത് നിന്ന് തന്നെ അദ്ദേഹം വിശദമായി സംസാരിക്കുമെന്നാണ് ഞാൻ പ്രതീക്ഷിക്കുന്നത്. തിരക്കേറിയ ഔദ്യോഗിക ജീവിതത്തിനിടയിലും സമയം കണ്ടെത്തി ULCCS-MatterLab ടോക്ക് സീരീസ് ഉദ്ഘാടന ചടങ്ങിൽ പങ്കെടുക്കാനെത്തിയ സജി ഗോപിനാഥ് സാറിനെ സൊസൈറ്റിയുടെ മാറ്റർ ലാബിൻ്റെയും നിങ്ങളുടെ എല്ലാവരുടെയും പേരിൽ ഞാൻ ഹൃദയപൂർവ്വം സ്വാഗതം ചെയ്യുന്നു. നാഷണൽ ഹൈവേ അതോറിറ്റി ഓഫ് ഇന്ത്യയുടെ മെമ്പർ പ്രോജക്ട്സ് ആയ ശ്രീ ആർ കെ പാണ്ഡെ സാറാണ് ഈ ടെക്ടോക്ക് പരമ്പര ഉദ്ഘാടനം ചെയ്യുന്നത്. നിർമ്മാണ മേഖലയുമായി ബന്ധപ്പെട്ട് അതീവ പ്രധാന വിഷയങ്ങൾ ചർച്ച ചെയ്യുന്ന ഈ ടെക്ടോക്ക് പരമ്പര ഉദ്ഘാടനം ചെയ്യാൻ എന്തുകൊണ്ടും യോഗ്യനായ ആളെ തന്നെയാണ് നമുക്ക് ലഭിച്ചിട്ടുള്ളത്. റോഡ് ട്രാൻസ്പോർട്ട് ആൻഡ് ഹൈവേസ് മന്ത്രാലയ അഡീഷണൽ ഡയറക്ടർ ജനറൽ പദവിയിലുള്ള സമർത്ഥനായ എഞ്ചിനീയറാണ് അദ്ദേഹം. മന്ത്രാലയത്തിലെ സുപ്രധാനമായ പ്രോജക്റ്റുകളെല്ലാം ചുമതല അദ്ദേഹത്തിനാണ്. ഭാരത്മാല പദ്ധതി സംസ്ഥാന ആദ്യ റീച്ചാപ്പാടി ചെങ്ങള റോഡ് 6 വരിയാക്കി വികസിപ്പിക്കുന്നതിന് പദ്ധതി ഏറ്റെടുത്ത് നടത്തിവരുന്ന ഊരാളുങ്കൽ സൊസൈറ്റിക്ക് അദ്ദേഹം നൽകി വരുന്ന നിസ്സീമമായ പിന്തുണയിൽ അദ്ദേഹത്തോട് നന്ദിയും കടപ്പാടും ഈ അവസരത്തിൽ ഞാൻ രേഖപ്പെടുത്തുകയാണ്. നമ്മുടെ ക്ഷണം സ്വീകരിച്ച് ഈ പ്രഭാഷണ പരമ്പര ഉദ്ഘാടനം ചെയ്യാൻ എത്തിയിരിക്കുന്ന ശ്രീ ആർ കെ പാണ്ഡെ സാർ വേറെ രാജ്യാന്തര ജേണലുകളും പത്രാധിപ സമിതി അംഗവുമായ ഡോക്ടർ മനു സന്താനം 200-ൽ പരം പ്രബന്ധങ്ങളുടെയും കർത്താവുമാണ്. കോൺക്രീറ്റ് രംഗത്ത് ലോകത്ത് നടക്കുന്ന എല്ലാ പഠനങ്ങളുടെയും പരീക്ഷണങ്ങളുടെയും പറ്റിയെല്ലാം സമഗ്രമായി വിവരിക്കാൻ കഴിയുന്ന ആളാണ് അദ്ദേഹം. ഡോക്ടർ മനു സന്താനത്തെ ആദരപൂർവ്വം ഞാൻ സ്വാഗതം ചെയ്യുന്നു. IIT ഗുവാഹട്ടിയിലെ സിവിൽ എഞ്ചിനീയറിംഗ് പ്രൊഫസറായ ഡോക്ടർ എസ് ശ്രീദീപാണ് മറ്റൊരു വിശിഷ്ടാതിഥി. ദ റോൾ ഓഫ് ജിയോ എൻവയോൺമെൻറ്റൽ എഞ്ചിനീയറിംഗ് ടുവേർഡ്സ് ദ സസ്റ്റൈനബിലിറ്റി ഡെവലപ്മെൻറ്റ് ഗോൾസ് എന്ന വിഷയമാണ് അദ്ദേഹം അവതരിപ്പിക്കുന്നത്. കേരളീയനായ അദ്ദേഹം ഈ വിഷയത്തിന് കേരള സാഹചര്യത്തിലുള്ള പ്രാധാന്യത്തിൽ ഊന്നി സംസാരിക്കാമെന്നാണ് സമ്മതിച്ചിട്ടുള്ളത്. മുംബൈ IITയിൽ നിന്ന് എഞ്ചിനീയറിംഗ് ബിരുദാനന്ത ബിരുദവും ഡോക്ടറേറ്റും നേടിയ അദ്ദേഹത്തിൻ്റെ പഠനങ്ങൾ പ്രൊഫഷണൽ സമിതികളിൽ അംഗവുമാണ് ഡോക്ടർ ശ്രീദീപ്. 100-ലേറെ ഗവേഷണ പ്രബന്ധങ്ങളുടെ കർത്താവായ അദ്ദേഹം 2014-ൽ ജിയോ ടെക്നിക്കൽ എഞ്ചിനീയറിംഗ് ഉള്ള ശംഷോർ പ്രകാശ് റിസർച്ച് അവാർഡും കരസ്ഥമാക്കിയിട്ടുണ്ട്. ഡോക്ടർ ശ്രീപാദിനെ ആദരപൂർവ്വം ഞാൻ സ്വാഗതം ചെയ്യുന്നു. ഇന്ന് നിർമ്മാണ മേഖലയിൽ അതിവേഗം പ്രാധാന്യം നേടിവരുന്ന സാങ്കേതികവിദ്യയാണ് 3D പ്രിൻറ്റിംഗ്. ഈ പ്രിൻറ്റിങ്ങിൽ ഉപയോഗിക്കുന്നത് പ്രത്യേകതരം കോൺക്രീറ്റ് ആണ്. ഇത്തരം കോൺക്രീറ്റ് വികസിപ്പിക്കാൻ ബെൽജിയത്തിലെ ഗൻറ്റ് യൂണിവേഴ്സിറ്റിയിലെ മാക്നൽ ഫാൻഡെയ്പെറ്റെ എന്ന ലബോറട്ടറി ഫോർ കോൺക്രീറ്റ് റിസർച്ച് എന്ന സ്ഥാപനത്തിൽ നടന്നു വരുന്ന ഗവേഷണത്തിൽ പങ്കാളിയായിരുന്ന ആളാണ് ഡോക്ടർ AV രാഹുൽ. സാധാരണ കോൺക്രീറ്റിൽ നിന്ന് 3D പ്രിൻറ്റിംഗ് കോൺക്രീറ്റിനുള്ള വ്യത്യാസങ്ങൾ, അതിലെ ചേരുവകളും അനുപാതങ്ങളും, അതിൻ്റെ സ്വഭാവവിശേഷങ്ങൾ, ഇതിൻ്റെ ഗുണമേന്മ പരിശോധനകൾ, ഉറപ്പ് പരിശോധന തുടങ്ങിയ സാങ്കേതിക വിദ്യകളൊക്കെ പറഞ്ഞു തരാൻ കഴിയുന്ന ആളാണ് അദ്ദേഹം. IIT തിരുപ്പതി സിവിൽ എഞ്ചിനീയറിംഗ് എൻവയോൺമെൻറ്റ് വകുപ്പിൽ അസിസ്റ്റന്റ് പ്രൊഫസറായ ഡോക്ടർ AV രാഹുലിനെയും ആദരപൂർവ്വം സ്വാഗതം ചെയ്യുന്നു. MatterLab മാനേജർ ഫ്രെഡി സോമനാണ് ഈ ഉദ്ഘാടന ചടങ്ങിൽ നന്ദി പ്രകാശിപ്പിക്കുന്നത്. അദ്ദേഹത്തെയും ഔപചാരികരുടെ പേരിൽ സ്വാഗതം ചെയ്യുന്നു. ഈ പരിപാടിയിൽ പങ്കെടുക്കാൻ ഞങ്ങളുടെ ക്ഷണം സ്വീകരിച്ച് എത്തിച്ചേർന്നിരിക്കുന്ന വിവിധ സ്ഥാപനങ്ങളിലെയും വകുപ്പുകളിലെയും പ്രൊഫഷണലുകൾക്കും സാങ്കേതിക വിദഗ്ധർക്കും എഞ്ചിനീയർമാർക്കും ഊരാളുങ്കൽ സൊസൈറ്റിയുടെ ഭാഗമായ പ്രൊഫഷണലുകൾക്കും മറ്റെല്ലാവർക്കും ഹൃദയം നിറഞ്ഞ് സ്വാഗതം ആശംസിക്കുന്നു. അതുപോലെ RO മീന സാറിനെയും സ്വാഗതം ചെയ്യുന്നു. ഇത്രയും പറഞ്ഞുകൊണ്ട് നന്ദി, നമസ്കാരം.
Thank you, sir. Thank you for the welcome address. Dr. Saji Gobinath, Present Vice Chancellor, Kerala Digital Sciences and Innovation Technology, Professor, IIM Kozhikode in the year 2020, Director, Indian Institute of Information Technology and Management, Kerala, and CEO of Kerala Startup Mission, Government of Kerala from 2017 to 2020. Dean of IIM Kozhikode from 2011 to 2015. Director, TA Pai Management Institute, Manipal from 2009 to 2011. Dean of Bennett University, and he also serves several national committees on education.
Good morning. Honorable Chairman of ULCCS, Sri Rameshan Palleri, the Chief Guest of today, Sri R.K. Pandey, the expert speakers from IIT Madras, IIT Tirupati and IIT Guwahati, family members of ULCCS, MatterLab, and other invitees and guests. I consider it a great privilege to be a part of today's ULCCS-MatterLab Tech Talk series, because as most of us in Kerala knows, type of changes ULCS has brought in the infrastructure construction professionals, and the research lab, MatterLab, which got inaugurated a few months back, is actually taking that to the next higher levels. I believe with this MatterLab Tech series, Tech Talk series, which is starting today, the knowledge, the latest research trend are going to be imparted to a large number of stakeholders, including academics, professionals, government officials, and others. And that is really needed because, as we know, that the country is actually on a growth path. I was talking to Sri Pandey that one thing which is visible in our country today, wherever you go, any part of India you go, is the type of change happens in the public infrastructure, especially road infrastructure. Whether it is go to the Himachal, or whether it is a very difficult part of Jammu Kashmir, or the other part of India, maybe the central India, or even in Kerala now, you see the huge change which is happening. Some of us who have traveled during 1990s and 2000 in other part of the world, even so-called not so well developed countries, we always used to wonder when we are going to get such infrastructure in our country. And today we are very proud that our country is actually growing in a very, very fast manner in that space. Now, this is actually going to lead to a huge amount of development for the country per se. Our Honorable Prime Minister has given the last Independence Day a very big challenge to all of us. He says that next 25 years is going to be the Amrit Kal, where by 2047, India has to become 10 times what we are today. Today we are a 3 trillion economy. We have to become a 30 trillion economy. And that is not a very small challenge. It's a huge challenge. I'll come back to that a little later. And that also is the context in which we should actually start looking at this whole tech series which is starting today. So I thought maybe two aspects I will briefly touch upon before we go into the detailed technical talks, which we'll see. As we know that when I was heading a startup mission, people used to ask that why Kerala doesn't have too many startups when you compare with other part of India, especially towns like Bangalore or Hyderabad or NCR region or Bombay. And we were wondering this question because government was doing quite a bit and supporting the startups. Why it is not happening? Then we found a very key reason, and that's a key reason in Kerala. If you look at many part of India, and that is more so in other part of the world, the development is always driven by, the ecosystem is always driven by the industry. The government only supports it. Unfortunately, in Kerala, we don't have that so far. We have several very successful industries, but how many of them have really contributed to development of ecosystem? Very few, right? You don't have academies which has been set by any of our so-called well-known industries. That is basically where ULCS is making a difference. In fact, sometime back when the inaugural address, chairman said that ULCS has got a mission of societal development and roads are incidental. It's like what Tata says, we also make steel, but we do a lot of other things to do that. It is exactly the same thing what ULCS is also trying to do. And I think that is basically the philosophy in which, and we are very fortunate that some organization is coming forward to create an ecosystem of expertise, ecosystem of knowledge, and ecosystem of talent around us. So be it the MatterLab, be it the IIIC, be it the work ULCS do, I think that's a philosophy in which we need to actually drive. And that sort of change makers, and I believe that many others are also get motivated by the way ULCS is doing, and we'll have many such in the days to come. And this is more so, especially when you look at the academic ecosystem. Now we have a challenge with the academic ecosystem that leaving some of the top institutions like IIT Palakkad or NIT Calicut or some of the very top niche institutions, a large number of institutions are devoid of the type of expertise which is required to create talent which need to drive the next level of growth in India. And that is happening because it is not because the colleges or institutions are bad or teachers are having a limitation. They are not really having the opportunities to work on. You go to MatterLab and see the type of equipment there. No college can afford that. It's impossible because you really require someone who has large industrial products only can do it. Colleges can do a much smaller level on that. So if a student or a teacher get exposed to such things, that's the time they will be able to make what industry wants, the day one professionals. I mean, I come from an academic space, so I always used to feel bad when somebody says that our students are not employable. Right? That's a common criticism we always have. But ask this question, those people whom we say are not employable are the ones who have actually made great things in the country, right? The lowest cost space expedition, the best buildings, the very complex automobiles, leading major institutions in the world. How is that possible if they are not unemployable? The reason is very simple. When colleges provide them knowledge, the immediate skills are actually provided later in the industry. But today's industry wants people who come out with knowledge and skills. And that you expect the colleges to provide that infrastructure is out of question. It's very difficult. That's basically where an open research, open facility like MatterLab become a very relevant. And I very strongly advocate those of you from academia to make best use of this facility because many times we also are reluctant to start looking at best use of the facility. Start doing things which the video espouse, courage. When 5 people or 14 people were thrown out of the jobs in 1925 with 34 paise, They thought that they can actually make a difference against British. This is a very classic case of an organization which created a new way of freedom struggle through creation of enterprise. The other is maybe Bengal chemicals, which is well documented. So what I mean to say is that courage which ULCS has shown to us. So when I was associated in some way with ULCS from 2004 onwards, and when this concept of creating a IT park was mooted, and I'm sure the chairman remembers this. We went to, I mean, that's time when ULCS is not this big. It's much, much smaller. And we went to many of the banks and other things. They said, why are you doing all these things? You're a labor cooperative society. You should make roads. You should have you should have people who just do the tarring and things like that. And from there, we said that when we develop, it has to be, the inclusion happens only when the entire society becomes involved in it. And that's basically where this is happened. Cooperative societies across the world has a challenge, because some of you know about cooperative knows that cooperative societies generally doesn't reinvest their wealth, because the members because you don't have a share value which goes up, so that you don't get a market valuation as such. So conventionally, cooperatives in the world are never diversified, because they always believe that you put back, if you make money, give it to their shareholders. That's the only way it works. Again, ULCS has proved differently. They say that the only way you can grow is through diversification. And that today, again, I don't know how many in Kerala knows that after Mondragon, and if you are a little bit know about Mondragon, otherwise you Google it, or if you don't want to Google it, ask ChatGPT what is Mondragon. It will tell you. It is a place where everybody breathes cooperativism. It's the world's largest cooperative haven in Spain. It's very, very popular globally, very huge return. And Mondragon Cooperative Society is world's largest cooperative society. The second today is ULCS. I don't think too many people know about it. Not once. No, once when India won the World Cup, Gavaskar said that somebody calls it a fluke. But when we win after Benson Hedges, we win further trophies. It cannot be a fluke. Same thing is here. It's not a fluke. For last 3 years consistently, ULCS is ranked number 2 after Mondragon Industries and Utility segment. That is the power of the thinking differently, thinking courage. The third thing, which is again different, is that as a labor society, what is the primary purpose one should have? Give work to the labor. And if you want to give work to the labor, you should not have mechanization, right? Because that's the only way people work. If I do mechanization, jobs are out. And that is the third myth which ULCS has busted. It showed that if you really wanted to make labor's dignity of labor goes up, you need mechanization. If you really wanted to grow much, much further, I still remember chairman speaking about when you think about ready mix concrete versus concrete mixing at a location, the number of labor involved in these two are very different. But the advantage is that the amount of work you can do goes exponentially in that. And this is a proof of that. So what I want to tell all people here who are from academia and from the industry is that ULCS is not just looked at as a cooperative society. It is also a society which showed that counterintuitive thinking is the way forward. And I think the next bit they have done is this MatterLab and the tech series. So it is generally in that's the context in which many of our industries did not grow, is that they never thought, they think that if I am actually having a knowledge, if I have a lab and I do a best thing in that lab, why should I share with somebody else? Competition, right? I'm creating I am empowering my competitor. So I am actually giving this knowledge to somebody else. So I should not do that. I should only keep it to myself. This is a normal, conventional thinking. But that is through the tech series, ULCC is bursting. It actually showing that the only way India can grow is not only by one ULCS. You need 100 ULCS to come. And if 100 ULCS come, still we have, I'm sure that Sri Pandey will agree with me that still we really require infrastructure. In another context, where I still remember in 2006, in a very different context, in a very different room, we had a meeting of people like this, where we actually brought in another set of technologies in another industry called footwear industry. Same case, like industry was not doing that well that time. They did not have too many newer technologies. We brought newer technologies, and today footwear cluster in Calicut is actually one of the best in the country, maybe second or third in Asia. So the point is that collective development and collective ecosystem development is actually the key thing if you really wanted to grow further. And that is basically where I think the tech series talks have to be taken in the right earnest. The type of experts we have, people who have worked in this area, and that's the type of knowledge which is getting imparted as such. So this is very relevant because if you look at today's world, and I come from a digital space, or I work on digital space, and the 3D printing which Professor Rahul is going to speak about is an example of how a digital and physical come together. And if you look at the digital world, it's different from the earlier worlds because the time in which the technologies come to us is very, very short. And in a very short period of time, technologies becomes very popular. So you think about AI being used in defect detection, or you think about sensors being inbuilt into the building structures where buildings started speaking to you. All these technologies are already coming and start practicing as such. Now, when you are looking at a very short period in which technologies are going to come to us compared to the past, be it the automobile technology or the electricity, which took years for people to adopt, the digital technologies take a much, much shorter time. So which requires people to be upfront in the technologies. And that makes we need to actually run very fast. We need to be aware of what is happening in the world very, very fast. More so in our country, because when Prime Minister said that we need to make ourselves $30 trillion economy in 2047, those of you who have got some background in management will immediately do a back of the envelope calculation. Tells that it means India has to grow consistently for next 30 years at around 12% per annum. In the entire history of India, we never grew more than 9%. So this is a challenge which PM has given. The challenge which PM has given is that it's not 1 year, 2 year. It is for the next 25 years, country has to grow at 12% per annum. And only way we can grow is our infrastructure have to be developed. And once infrastructure has to be developed, again we have two challenges in infrastructure. A, the productivity has to go up. We need to have the time of infrastructure development should come down. Now, we know in Kerala, when we acquired the land and when the infrastructure has come, so many years, right? And when you build, how many years it is taking? You really require newer models. You completely require newer materials. You really require newer methodologies to ensure that this time period of construction has been shrunk to a large extent. The time period in which the cost in which the product is getting delivered is shrunk. Now, when I say cost, I again want to repeat here because this is again a wrong notion, especially with regulatory authorities, that the cost is the landed cost. It is not landed cost. The cost should be cost of ownership. You may be spending more money on a steel structure. You may be spending more money on a prefab. But your total cost of ownership, when you take the time and the maintenance and the entire life of it, will be much shorter. Now we require, in fact, Chairman briefly mentioned that regulatory authorities also regulations also have to adopt some of the things, which is very true. You need to actually start accounting for some of these aspects, which unfortunately is not there. I'm sure that these sort of platforms also will bring debates and policy discussions like what IRC used to do in some of the in the highway and other contexts. We will also have some policy discussions in the days to come on this. But important point is that we don't have a choice now. If India has to compete, and I'm sure that if you look at different periods of time, in 1800s were the period of Europe, first industrial revolution. 1900s was the period of America, second industrial revolution. The last part of 1900s was the period of China and Taiwan, Southeast Asia, the third industrial revolution. Naturally, the fourth industrial revolution, we should lead. India should lead. That's the context in which we should look at. And if you really wanted to lead that, we need to ensure that we deliver things very fast, high quality, and with a high level of efficiency and effectiveness. And that is basically where the technology is going to help. And I'm sure that this tech series, starting today, which brings in very interesting topics in front of us, and across the period, such tech series talks are going to enlighten us and create the ecosystem which is what is required for the state and the region and the country to prosper. It's a very great privilege for me to preside over this inaugural function, and we are very fortunate that we have a person who has built the country. In fact, I always used to say that our generation should be very proud, sir, because when we started our career in maybe 1980, late 1990s, and today, look at the country, how it has changed. And we should be really proud. Those of us in 50s should be very proud. Chairman, we should be proud that we are the ones who actually made a big difference to this country. And we have really a person who has done that in his own hands as the member projects of National Highway Authority of India to inaugurate this. It's a privilege for us to have you, sir, here. And I'm sure that he will enlighten us with the type of development which is happening. And let me start by wishing ULCS, the MatterLab, and the Tech Series all the very best to create a very vibrant ecosystem for the infrastructure and construction industry in the state. Thank you very much.
Thank you, sir. Thank you for the thoughtful message, and that was truly inspiring. Thank you, sir. Thank you so much. Now, may I invite our Honorable Chairman, Shri Paleri Rameshan, sir, to please join on the dais. Also, I may take the pleasure in inviting our chief guest, Shri R.K. Pandey, sir, Dr. Saji Gopinath, sir, and the speakers of the technical sessions, Dr. Manu Sandhanam, Professor Dean, IIT Madras, Dr. Srideep S., Professor, IIT Guwahati, Dr. Rahul A.V., Assistant Professor, IIT Tirupati, and Mr. Shaju S., Managing Director, ULCCS Private Limited, Mr. Surendran M.M., Director, ULCCS Private Limited, Mr. Shijin T.T., Director, ULCCS Private Limited, Mr. Freddie Soman, GM, MatterLab, Dr. A.V. Thomas, former Director, Adani Institute, Mr. B.L. Meena, Regional Officer of NHAI. So please, I invite everyone for lighting the lamp. Thank you, sir. Please be seated. Our chief guest of the day, Shri R.K. Pandey, sir. Sir is the member projects at National Highway Authority of India since 2015. He joined the Ministry of Road Transport and Highways as an assistant executive engineer in 1986 through Central Engineering Services. He worked in various positions in the ministry and rose to chief engineer in September 2011. He also served NHAI as a chief general manager from September 2009 to 2011, when he became chief engineer in the ministry. He also acted as the additional DG in the ministry. Mr. Pandey, sir, has been responsible for completion of the remaining NHDB Phase 3 to Phase 7 projects and was given a major responsibility for the Bharatmala project of the Government of India. We are truly honored and privileged to have with us today Shri R.K. Pandey, sir, And I kindly request you to please deliver the inaugural address. Sir, please.
Distinguished invitees, speaker, delegates, and friends, very good morning. Indeed, it's a privilege for me to be here and share my experiences and views. At the outset, I would like to thank ULCC for giving me this opportunity. My association with ULCC was more than 20 years old. As Dr. Saji said, in 2004, they were not as big as today. I am talking about something around 2001 when they were trying to come into the construction field. And they have taken our first project when Madam Sulochana was chief engineer here and I was RO. And they have completed our first project well in time. It was a small project and today they have grown in a form of big company. It is not the size of the firm, it is the mindset. In fact, I have seen number of contractors who have grown, but nobody has grown like this. Why it is different? Because their mindset is different. It is not earning profit, but more of sharing profit. That makes them different than the other contractor. And I'm sure they'll continue to do so and grow much bigger. In the industry, we used to discuss and we always feel that there is a large gap between the practicing engineer and the academia. We are not doing any research. Why we are not doing any research? Because as a practicing engineer, I have to construct road, I have to construct 40 kilometers a day. I can't wait for any research and I can't do any research. When it goes to the contractor, the sole motive is to earn profit. Whatever he gets, whatever he can do at the cheapest rate, he'll do it. So what we did is we have left everything to the academia to do it. The research is the domain of the academia. And when they'll do it, we feel, oh, there is mismatch. Whatever they are doing, I'm not in a position to implement, and whatever are my requirement, he is not doing the research. So it has been the position, and I'm sure the event like this will be a step forward to reduce this kind of gap. Friends, as you heard, I'm from the highway sector. Highway in our country is the most preferred mode of transport, and majority of our freight as well as passenger, when I'm saying majority, it is more than 70%, is through the road transport. For road transport, we are fortunate in the sense that we have the second largest road network in the world. The length of our road network is of the order of 62 lakhs kilometer. And this has been divided into a number of categories depending upon who is the custodian. As far as the first category, which is the national highway, central government is the custodian of development of these roads. And when I see in terms of the magnitude of this national highway, it is around 1.43 lakhs kilometer. When you compare with 62 lakhs kilometer, it is nothing. It's a very minuscule percentage. But at the same time, these are the main arteries which are carrying more than 40% of the freight and passenger traffic. So these are the most important roads and are being developed by the central government. For development of the roads, initially the roads were in the domain of the public. It means the responsibility of the development of the roads was resting with the government. But we realized that we have constraint of budget and we are not in a position to take up the work in a big way. This particular aspect was highlighted when a very exhaustive study, which was called road user cost study, was completed in around 85-86. it has given us a kind of results that if I'll improve road, what kind of benefit will accrue to the society. Everybody knew that if we'll improve road, you will save time, you will save petrol, you will save diesel, you will save tire. But we didn't have the mathematical model. This study has given us the mathematical model, and with the help of this mathematical model, what we could prove is if we'll spend 10 crore, the kind of return will be of maybe 3 crore or 4 crore. It means very high RRR. When this mathematical model was available with us, we could impress upon the government that huge amount of funds are required for road improvement, and if we can take up, it will give back to the society in a big way. But we had the limited resources, so private sector was open up, and the road sector was entirely open up for the private sector participation. As a result, our whole resources for development of roads have been augmented, and we could take up this kind of program. Coming to the the how the role of the highway engineers changed, what we did, what is the kind of technology, and how the technology helped us. What I'll try to do is I'll tell you the past history of the road and where we are, what we are looking for. Then you will realize how the technology can help us in meeting our objective. So the first ambitious, as I said, when we made and address the issue of resources, we have taken a first ambitious program, that was National Highway Development Project. The whole idea of this project was to improve around 42,000 kilometers of national highways. And the majority of the source was from the private sector participation. GQ, Golden Quadrilateral, which connects four metros in the country, North, South, East, West corridor, are among the first two phases of the NHDP. We started implementing NHDP, but after a gap, we realized we made some mistakes. And what are those mistakes? What we did is, in eagerness to take up the projects, we awarded very in the preliminary stage without completing the land acquisition processes or pre-construction activities. We were under the impression by the time the parties will come take up the work, we will be ready, but unfortunately it didn't happen. As a result, in a year somewhere 2011-12, we got a big setback, and our entire private sector participation failed. When the private sector participation failed, we started thinking how to implement our projects. Then came the EPC contract. EPC contracts are nothing but the lump sum contract provided, funds are provided by the government. It was the compulsion for us to do so, because otherwise the entire construction industry will be doomed. So we introduced this EPC, but at the same time we knew that I can't continue with EPC. It is a kind of a medicine which we are giving it to the industry for a very short time, and in the meantime we'll have to make some permanent arrangement. So we brought out number of other options, and hybrid annuity is one of them. Hybrid annuity, what we used to do is, we'll pay a portion of construction cost now, balance in the form of annuity. It means I am leveraging my available resources, and it showed the result, and we are again back on track. Today, I can say proudly, we have gone as high as 37 kilometers a day, which can only be done by the world. Nobody, nowhere we have this kind of ambitious program which is being implemented. We are fortunate, as Dr. Saji said, our generation is creating and should be very proud. We are also proud. During last 2 years, we have created number of world records. Whether it is construction of cement road, whether it is construction of bridge, whether it is construction of concrete road. In all the fields, we are creating records. Now coming to the again back to the development of the national highways. This program NHDP was at the end. We were in the process of launching another program that is called Bharatmala Pariyojana. In these 20 years, technology also, a lot of technological changes took place, and it has impacted us as well. NHDP, what we did is NHDP because that time I have very limited data, and I have very limited data analytic capacity. What we did is, on the road cross section, I'll count the traffic and see where the present traffic has exhausted the capacity, I'll widen it. That was the way, and that was the whole philosophy of launching NHDP, and we developed NHDP. In the meantime, everybody was started talking about whole life cycle cost. So we also started talking about whole life cycle cost, and then the whole life cycle cost, how it evolves. Initially, for us, whole life cycle cost is nothing but the construction cost. Then we added maintenance cost. We said construction plus maintenance, which is, during the whole life cycle, which is the least, we'll opt for that. Then came vehicle operating cost. As I told you in the beginning, we got the mathematical model, an excellent model developed in Indian conditions. So we started taking care of vehicle operating cost as well. I'm not saying that we have stopped, because today the problem is people started talking about environment. But I don't have any mathematical model today to do the environmental costing. But I'm sure that day is not far when people like us sitting together start thinking and come out with the environmental cost. Because that is one thing which is really required. I'll try to dwell upon before I'll digress from the main philosophy of Bharatmala. So when I have all this, I have a lot of data. I have started collecting data and data analytic capacity. I have data among 600 districts, what kind of freight is originating from one place and going to another place. When I have that kind of data, I have mathematical model available, whole life cycle cost analysis, which takes into account vehicle operating cost as well. Now, think of two situations. In the NHDP, what I did, I have widened the existing roads. Because I have the network, wherever capacity adjusted, I have upgraded, improved the capacity. Now I have data of traffic, which says, I'm giving you an example. How much traffic moves from Delhi to Mumbai? Delhi to Mumbai, I have an existing corridor which goes Jaipur, Udaipur, and Baroda and Mumbai. If you'll see on the map, you will find that the road is going slightly like this. It makes a moves westward, southward, then southward, eastward. If I'll make a straight crow flight alignment, what will happen? I have data that how many trucks are moving from Delhi to Mumbai. And they are forced to travel on this road because this is the developed road. And then when we did the analysis, we realized if I'll reduce this distance, probably it will be cheaper. And the alignment which we are developing now is a crow flight straight alignment, which is around 170, 180 kilometers lesser than the existing road. It means each truck is saving 180 kilometers per trip between Delhi to Mumbai. Now, what we did is, if I'll develop the existing road, which is already developed, what I'll have to do is I'll have to make 6 lane or 8 lane. I have to only add 2 lanes. If I'll have to go for a green field, I'll have to do more construction. So construction cost certainly will be high. Construction cost here will be low. But there is another interesting fact that whenever we'll go for land acquisition, in the land acquisition, basically there are three type of land. One is the agricultural land, another is the residential land, and another is the commercial land. Commercial land rate may be 10 times. If you are going by the side of the existing national highway, majority of the land, because all urbanization take place by the side of your road. So cost of the land acquisition was much higher as compared to greenfield. And when we computed that, of course, when I'm following the existing alignment, I need only 30-meter additional. If I'm going when I'm widening existing road, I need 30-meter. When I'm going greenfield, I need 3 times more land. But in terms of the value of, in terms of the cost of the land, it is cheaper. It is not only the cost of the land, I need not to pay for any structure because it is greenfield. It is not only structure, invariably you will find whenever we develop a road, all the utilities will come by the side of that road. In the greenfield, I don't have any that utility. So in terms of construction cost, pre-construction cost, vehicle operating cost, we realize that greenfield alignments are much cheaper than the improving the existing road. So the Bharatmala main emphasis is on developmental greenfield crow flight alignment. And we are developing 27 such corridors. It is not only from the point of view of the costing alone, even in terms of indirect cost. You know, as everybody says, you go to any small country, they'll have expressway. We didn't have any expressway. Why we didn't have any expressway? Expressway is nothing. Expressway is access control road. When I am widening my existing road, how I can deprive others who are staying there since long and make it expressway? So I could not develop expressway for simple reason, because I was developing my existing road. In Bharatmala, invariably, I am developing all the expressways. So this is the major, shift in our planning. It is not only in planning. And such a huge program, what I'll have to have? I'll have to have a lot of DPRs prepared, readily available. And when we started and introducing it in our documents, we were little apprehensive what will happen, how profession will respond. But today, it's a routine. Everybody has the facility and they are doing it. It has brought up new business now. That time people were talking, I don't know what will happen if you put LiDAR on drone, you'll not get accuracy and this, that, what not. Now good available drones are available and we have good market and we are using it. Again, I need technologies for making the whole experience of the road user as a pleasant experience. It is not the construction of road alone. Again, in our mindset also, we started thinking differently. When we started our career in the 80s, for a highway engineer, knowing bitumen, aggregate, soil is good enough. If I know all this, I am a good engineer. What is my role and responsibility? I'll have to construct 2-lane road, let people move. If somebody is going outside the road, it is driver's fault. It is not my fault. I did my best. And if you are going wrong, it is your fault or driver's fault. So if you'll see the accident analysis of last 20 years, you will find most of the accidents are attributable to driver's fault. Then we realize we should not leave it like this. When people are driving, they may sneeze, they may take a nap, and it is not uncommon. So we should have all those facilities. Even if somebody sneezes or he takes a nap, he should be safe. So we, from 7 meter wide, we started thinking wider road and moving towards forgiving roads. So today, all our roads design, the concept of forgiving roads is there. It is my responsibility that if somebody is going off the track, I'll have to alert him. I'll have to provide all kind of information. So this is in the design part of it. Coming to the implementation part of it. Before implementation, let us talk about road safety. When we started building roads, we realized it is not the speed and the time saving. I'll have to take care of accidents as well. It is unfortunate part that we still have the dubious distinction of having maximum fatalities on our road. When we developed NHDP, the whole idea, whole vision was to remove deficiency and make it 4 lane, let people go fast. We have developed NHDP and then realized, of course, we have developed road, but unfortunately, we could not control accidents. On the contrary, the severity of accident increased. When I say severity, it means if accident takes place and fatality is there, then it's a severe accident. Why it is? It is but natural, because the speeds have increased. Then we realize what is the main cause of accident. Number one, at-grade junctions. So whole idea is to remove all the at-grade junction. Nobody should come on the man carriageway directly. They'll have to have some other facility where rather than coming on this, they'll have to converge. So in Bharatmala, we have taken care of it, and you'll find invariably now no at-grade junction. No at-grade junction, whether it is expressway or non-expressway, no at-grade junction. It is costing me, but we have. Again, when I talk about road safety, always people will say there are 4E, 5E, 6E, 7E, whatever it is, the engineering, enforcement, education, and emergency care. So when, again, I'll take you back to 30 years back, my role is engineering. I'll say emergency care, none of my responsibility. Enforcement, none of my responsibility. Somebody will have to take care. But the era of private sector participation, when I started using collecting toll, again, I'll have to think slightly differently. When I am starting collecting toll, I'll have to give some kind of services to the road user. Then what we did is patrolling vehicle and ambulance were deployed all those roads where we are collecting toll. And now it has become a practice. Any highway improvement program, we employed ambulance and patrolling vehicle. It means what I did is I have moved a step further. Forgetting about engineering alone, I started taking care of the emergency care. Now, because technology have moved fast, I'm in a position to collect a lot of data. Why I should not share this data with the public? So we started putting advanced traffic control centers, an integral part of the highway. Of course, I started with an idea that I'll provide information to the road user, which will make his journey safe, which will make his journey pleasant. But at the same time, this information I can share with the enforcement agencies, which will help me to make sure the traffic is behaving the way they are expected to do so. What is the end result? You will find as a highway building organization, we have broadened and taking care of emergency care as well as the enforcement part of it. The whole idea is to make our roads safer and journey pleasant. People can use it and enjoy it. These are the plus point of it. Coming to the Kerala. When I talk about Kerala, my small stint here as a regional officer, I used to travel from Talpadi to Trivandrum, particularly after Varapura Bridge to Kuttipuram. It's a very narrow road, and so that time we used to think, can't we widen this to 4 lane? Again, I got the opportunity, and I knew it very well that widening this road once means it is for one time and last time. It is because the Kerala is situated, the whole geography is this, that land is very scarce. It is a limitation, so we'll have to manage it. It is for the first time it had happened that we are managing within 45 meter ROW. And in 45 meter, we are providing 10 lanes. 4 lane will be through, and 6 lane will be through, and 2 lane service road on either side. This is the worst we can provide, what best we can provide it, and we are trying to implement. It gives me immense pleasure to tell you the entire corridor from Talpadi to Kanyakumari has already been sanctioned, approved, works awarded. And we tried to include number of underpasses, facilities, crossing facilities. Of course, I do admit that it is not possible for me to address the concern of each and everyone, but within the limited framework, whatever best we could do, we tried to did it. We have further plan, because this is one north-south corridor which is the lifeline of Kerala. There are 3 east-west running corridors which we'll have to implement, and most probably one corridor we'll try to take up this year. By the time, by the way, let me tell you, here we are spending maximum. You can't imagine the cost of construction per kilometer of our road is of the order of 100 crore per kilometer, including land acquisition. So anyway, let us again move forward. This is all plus side. What are our objective? What we would like to do it, where we feel that people still have, seeing towards us, they expect more from us. Number one, when we talk about highway construction, there are few challenges which we are facing. As I said, the cost of construction, 100 crore. Everybody is talking, why not? It should include. Why should cost should not be optimized? And when I'll say cost should be optimized, again, yes, again on the basis of the whole life cycle cost, we would like to bring down our cost. Number two is the pace. When I say people that we are building 37 kilometer a day, you will find every day in the newspaper this year they have done 12% less, 13% less. Everybody is expecting, why don't you move 40? And my minister says, why not 50 and 100? So this is a challenge. I'll have to do it. When I'll have to do that, it means what I'm looking for. I'm looking for very fast project preparation. I'm looking for all those technologies which can give me a faster pace of construction. Durability. As I said, when I am developing a infrastructure, it becomes lifeline. I can't afford to close that lifeline for a day. I am looking for all those kind of technologies which are, to be very frank, called maintenance free. Say, for example, let me tell you, for Delhi Mumbai, forget about Delhi, even Delhi Mumbai, most of the road now we started thinking about perpetual payment. Perpetual payment is nothing which lasts for longer, means literally it has lifelong payment. So we started using that kind of, to go towards those, meeting the requirement of cost optimization, meeting the requirement of fast construction. Again, I'm looking towards technology. I'm looking for new material. I'm looking for new equipments. That we'll have to think if we'll have to really achieve the goals. It is not only these, sustainability. When I said building 37 kilometer a day, can you imagine the kind of aggregate and soil I am using for construction per day? In Kerala alone, the requirement of aggregate for construction of 600 kilometer road is 10 crore. 10 crore metric ton. This is for already awarded projects in one state. How long I can have this kind of aggregate, availability of aggregate? It means I'll have to think differently. Again, I'm looking towards all the people sitting here to suggest me what, where and how to go about. Fourth important point is about the people's expectation. As I said, I started in the beginning. Initially, people were very happy when I'll provide them pothole-free road. Then they realized 4-lane road, nobody was, going to settle less than double lane, double roads. Then came, no, I don't want anybody coming from sides. Now people feel that you go on providing me information. I'm not looking for Trivandrum is 440 kilometer here. You tell me how much time it will take from here to reach Trivandrum. You just go on telling me, and this is something, putting milestone was very easy for me because it is static. Once I measured the distance, I put it. Telling you how far Trivandrum in terms of hours, it is dynamic, changing every now and then. But it is all possible. Everybody sees on map. Why I can't have that technology here? Put the people not traveling with mobile, they can see that Trivandrum is 4 hours. Trivandrum is 3 hours. It is raining, it is 3.5 hours. Some accident took place, it may be 4 hours. Everybody is expecting this from us. And that we'll have to provide. Again, I'm looking towards the technologies. I'm looking towards IT to help me and suggest me the solution. Tolling. It is the necessary evil. And one of the study of IIM Kolkata with TCI, then maybe 10, 12 years back, they concluded, of course, I have not gone through the whole study, I'm not subscribing to that, but they have concluded that whatever time you saved traveling Delhi to Mumbai has been lost in toll collection. So, okay, fine. We have moved to fast track, electronic tolling. But today, people started asking me, if you go to the even vegetable vendor, he accept Paytm, GPay, all kind of payments are acceptable to him. Why you are restricting to fast track? So I fully agree. I should have all the option. People before starting, they can pay sitting in the home, all the toll in the route, and they should go through. And it is possible. Nothing new. Only what I'll have to do is I'll have to bring that technology to the road sector. So, friends, we are changing. We are trying to satisfy the requirement of the road user. But yes, the way we are changing, people are also changing their requirement as their list, the wish list is much longer, and I'm looking towards all of you to give me the solution which we can implement and make life of people easy, fast. They can have faster travel, safer travel, and my best wishes to ULCC MatterLab. MatterLab is one thing really we were thinking about. When I'll have to achieve all this, economical construction, I'll have to environmental sustainability and all those, there will have to have organization like this. I'm sure all will contribute and move forward. Thank you very much.
Thank you, sir. Thank you for your thoroughly inspiring perspective words. There are a lot to take and also to think about from your words, sir. Thank you so much. Now, I request our Honorable Chairman, Shri Paleri Rameshan, sir, over to the dais to hand over the mementos. Sir, please. May I request our chief guest, Shri R.K. Pandey, sir, member projects NHAI, to please accept the memento as a token of gratitude. Thank you, sir. Let me invite Dr. Saji Gobinath, Vice Chancellor, Kerala Digital University, to please accept the memento as a token of gratitude. Thank you, sir. May I also request Dr. Manu Sandanam, Thank you, sir. May I request Dr. Rahul A.V., Assistant Professor, IIT Tirupati, to please accept the memento as a token of gratitude. Thank you, sir. Thank you, sir. Before moving on to the technical sessions, now we will go for a short tea break. We will have a tea break for 15 minutes, and I request all to be back for Dr. Manu Sandhanam's technical talk at 11 a.m. Thank you. Also, any emergency, please assemble at entry to the main entrance external parking area. Please note, in case of any emergency, please assemble at entry to the main entrance external parking area. Thank you. Moving on to the technical sessions. Professor Manu Sandhanam. Professor Manu Sandhanam is from the Department of Civil Engineering, and he is the Dean for the Industrial Consultancy and Sponsored Research at IIT Madras. Earlier, he had worked at Sika Corporation as a senior R&D chemist and at Purdue University as an instructor. His area of interest includes construction materials, concrete technology, high performance and self-compacting concrete, non-destructive testing, concrete durability, repair and maintenance of concrete and masonry structures, and supplementary cementitious materials. He is a member of the National Center for Safety of Heritage Structures, which focuses on scientific methods for the conservation of heritage structures. He also co-authored more than 200 plus journals, international journals, and conferences publications. He is active in various professional associations such as ACI, ICI, and RILEM. He is also a member of the editorial board in leading international journals like Advances in Cement Research, ASC Journal of Materials in Civil Engineering, Journal of Cement and Concrete Composites, etc. He holds a BTech degree in Civil Engineering from IIT Madras and Master's and PhD degree from Purdue University, USA. I invite Professor Manu Sandhanam for the first technical talk for the day on the topic moving towards performance based standards for concrete structures. Sir, please.
Good morning to all of you. It's indeed a pleasure to be here, and I really salute the vision. Hello. Yeah. So today I'm going to talk to you about moving towards performance-based standards for design of concrete structures, or more related to how we can actually achieve quality in concrete construction. Very often we see that concrete is a subject that is not treated very well in the field, right? Everybody is worried about design. Design these days is accomplished with very well-known methodologies, and there are software, there are design checks that help you design structures in very optimal ways. But very often when you translate this design to the field, a lot of the issues that come up in field practice are related to how effectively you can translate what's on paper into the actual structure. And more often than not, the problems are related with the quality of the concrete that goes into the structure and the way that it's actually put in, and of course all the processes that follow beyond this point, right? So just like cooking, right? We have all the ingredients to make a nice dish, but unless we put the ingredients in the correct way, in the correct amounts, the correct proportions, we really don't get the right taste in the dish. Same thing with concrete. So it's very important to look at what are the stages in concrete construction where we can really make a difference, and how we can actually go towards controlling the quality by adopting specifications that are performance based. Now, conventionally, we design concrete for compressive strength. We say M50 grade, M60 grade, and so on and so forth. And we assume that all other characteristics, right, your durability, your modulus, all of the structural characteristics are simply taken as a function of your compressive strength. As long as we achieve cube compressive strength in construction, everything is considered to be fine, right? What we do to achieve that strength is that we prescribe a type of cement for the environment, we prescribe the total amount of binder that is to be used, water cement ratio, and so on. And we say that as long as you follow this prescription, it leads you to a durable concrete. Okay, that's good, but it doesn't necessarily convey the entire thing, because there's a lot between the paper and the actual structure. On paper, you can put together a great design. In the real structure, there could be a lot of issues. We specify the cover for the service environment. So let's say we have an extreme environment or very severe environment, we specify the cover for different types of concrete elements. Now, whether this cover is achieved or not in the actual structure, we really don't bother checking that, right? We put in cover blocks, but we often know on sites handling is not always optimal. Vibration is not always optimal. Cover blocks don't necessarily stay in place. As a result, your cover varies. Now, if you're thought about durability by designing a structure with a 50 mm cover, if your cover goes down to 40 mm, that means that you have compromised durability by at least 20%, because cover is directly responsible for durability, directly. Now, of course, that doesn't mean that you can go on increasing the cover, because structural design does not permit you to do so, because the more the cover, the greater will be the crack width at the surface. So all that also needs to be considered while choosing the right kind of characteristics for your concrete. But nevertheless, the point I was trying to make is we don't check in the structure what happens. We just base everything on the 3 cubes that we make and store in ideal conditions, right? So research and field experience has shown that simply testing the compression strength on the cubes does not give us a clear picture of how durable this concrete structure is. We have seen so many premature failures. A lot of structures develop cracks, a lot of structures do not develop the kind of strength that we want them to develop, and so on. So unless we figure this out in the cube strength, for instance, if there's a problem with the strength of concrete in structure, if it doesn't show up in the cube, we'll never be able to point that out, right? Because the cube is the only way to check what's happening in the structure. So how do we ascertain that what is in the cube is exactly the same in the structure? So that's where we need to move towards gauging performance and ensuring that we are able to achieve that performance in the structure, not just the cube. Now, performance, or in this context, we are talking primarily about durability, right? Strength is not something that we worry about anymore. I mean, there are projects in which strength also sometimes is a concern, but that's more because of lack of proper quality control. But in most sites where quality is controlled fairly well, strength achievement is not really a big deal anymore, right? At least for the conventional grades of concrete up to about M40, M50, achieving strength is not a big problem. But durability is where we really can make mistakes if we don't choose the right strategies for concrete construction. Now, durability itself, you can break it down into the concrete system, which consists of the materials that go into making concrete, your binder type, binder content, aggregates, admixture, and so on. But there's also a process component, right? How well have you mixed the concrete? How well have you compacted the concrete? Transportation, is the transportation appropriate, or is it likely to cause a problem? For instance, today we are increasingly using flowable concrete, like self-compacting concrete. If the transportation is not done carefully, there is a chance of segregation. Your curing. Now, today increasingly we are having shortage of good quality water on sites. We are shifting towards curing compounds, right? What is the efficacy of the curing compound? Have we established a methodology to check that, right? Temperature of concrete. Today it's increasingly becoming a problem because we are designing concrete with very massive structural elements, right? When you increase the size of concrete elements to more than 600 millimeters in thickness, the heat developed in the core starts becoming a matter of concern, especially because many of these constructions involve high-rise buildings where we are using already grades of concrete that are M50 and above, which have a substantially high cementitious content. So potential for heat development is quite high. Now, if you're not paying attention to temperature, you may end up getting a lot more problems in the initial stages. Workmanship. Now, this is something which we have a lot of difficulty controlling, right? That's where there is often a distinction between performance and quality. Performance we can always measure. Strength is a performance. Some durability parameter like water absorption is a performance. What do we do to measure quality? How do we measure quality? It's very difficult, no? Your structure looks perfectly fine on the outside, but in some locations your cover is as low as 10 millimeters, but you don't see it. Quality is something that you have to see in order to assess. If you're not able to see it, if your structure looks flat with no honeycombs, but there may be massive air voids inside because of improper compaction, what do you do then? Your quality is good from the surface, but actually things are not really what they should be like. So that's the most difficult part to assess, workmanship and quality. But what do we do about all of this? I mean, you can't start saying that in your code you can't put conditions like you need to mix for 5 minutes, you need to mix for 10 minutes, your temperature of concrete. Temperature can come into the code for massive structural elements. But how do you manage that temperature? All of those things are not necessarily covered in codes. That's where specifications become important. Now, every job has to meet the demands of the contract, job contract, or the job specification. Very often, engineers on site seem to think that the code is the ultimate authority. No, for a construction project, your contract or the specification is the ultimate authority. You need to make sure that you are constructing as per the conditions stipulated in the specification. The concrete has to meet the demands of the specification. And the client has every right to demand something from the concrete in the specification that may not necessarily be there in the code also, right? So very often we try to take refuge behind the code, saying that code does not permit this, code does not permit that. But the code also tells you in fine print that the engineer in charge of the construction project can do anything he wants as long as there is sufficient evidence backing the decisions that have been taken. So all the numbers that are given in the code are only to help to move ahead with something if you don't have any information. But projects, we have executed so many local materials, we have experience with so many local materials. Why can't we be more innovative in the way that we do design with concrete? And why can't we control quality of concrete in ways that are not necessarily described in the code? Okay, so that's where we need to be a little bit more innovative. We need to take refuge not under the code, but under all the information that is available in the world. There's tremendous amounts of information, and increasingly world over, construction specifications are getting a lot more challenging, primarily because they brought in elements of how to control durability. Now, of course, the other part of durability is the environment you're designing for. There are processes, physical and chemical, that may affect the quality of your concrete in the long run. But this is something that you need to work for. You need to understand what are the possible challenges of working in a given environment, and how do we bring that into the design and control process of your concrete. So that's where this approaches of designing concrete come in. You have prescriptive approach and performance approach. In prescription, of course, we can avoid deterioration entirely. For instance, when we're talking about Kerala, the biggest form of deterioration will be chloride-induced corrosion, because such long coastline, entire structure is almost very close to the coast, right? So entire state is very close to the coast, so you mainly have problems of chloride-induced corrosion. Now, in such a case, if you start using stainless steel for all your construction, most of your problems will be avoided. But why would you use stainless steel? It is not just if the cost increase of using stainless steel is simply not justified, right? So you can use materials that are not necessarily going to deteriorate, but that is simply not cost effective. So we usually typically use the deemed to satisfy approach. What is typically followed by today's codes, IS 456. Of course, IS 456 2000 is still being practiced in 2023. IS 456 2000 would have been started to be written in 1995. So actually we are working with technology that was nearly 30 years old, okay? So I have to promise you that as being part of the IS 456 working committee, that the new draft is underway. I'm hoping that 2023 will be the year that we'll release that draft, at least for wide circulation, get people's comments back on it. And several of these concepts are getting modernized. We are trying to catch up with leading international standards like EN and ASTM. Hopefully we'll get there. Also, essentially we are looking at prescriptive requirements on materials. Just saying that, okay, you use so much maximum water cement ratio, use so much cement at least, so much grade of concrete, and then you can actually get durable concrete. So, but then we want to move towards this performance approach where we gauge the quality of the concrete with performance-based tests and indicators, right? We do material selection based on what we are able to get as a performance in the concrete, and rate the concrete quality by choosing different material combinations and assessing the ranking of the best. The other approach, of course, is through modeling. Now, that's the most well-developed form of performance specifications, where knowing the quality of the material that I have, or knowing the composition of the material I have, and the kind of proportions that I'm going to mix it in concrete, I should be able to then model how this concrete is going to behave in that particular service environment. So there are several things here which we need to know. That's why modeling is the most complicated form of doing a performance-based design. So for now, most people are trying to look at performance-based tests and indicators as a way to define performance of the concrete. Just to give you an example, of course, compressive strength is actually a performance, right? We measure compressive strength still. It is a performance criterion. When we do the 3 cubes stored in ideal conditions at 28 days, we take out and measure the strength. It's a performance criterion. But other performance criteria can also be used for durability, let's say. For instance, cover depth. Now, we have already specified cover depth. Why does it become a performance criterion? it becomes a performance criterion when I actually do measurement of the cover after construction. So let's say I've constructed 100 cubic meter of concrete, right? So the spec can say, okay, at least out of 100, for 5 cubic meter of concrete, the structural elements corresponding to 5 cubic meter of concrete, try to measure the cover and see that the deviation is not more than so many %. That's a performance specification. Just saying that for extreme environment cover should be 75 millimeter for a column, it's a prescription. Yeah. No, that's where I'll get to that. I'll get to that. It's a good question, because what happens is when these are for new structures. We are defining performance for new structures. So for new construction. So let's say maximum shrinkage or permeability, there will be an appropriate age which will be defined at which you are measuring. In concrete technology, we are very happy with the use of 28 days. For some odd reason, we always want 28 days, because I think it's nicely convenient that it's 1 month or 4 weeks or whatever it may be, right? So we have that 28-day picture always, that we measure our properties at 28 days, and that's the performance that you want in your structure, right? I'll come to the complication associated with that. Just before I give you the prescriptions, when we do prescriptive specifications, we prescribe the type of cement, water cement ratio, the curing duration, curing method, and so on. We are not prescribing anything in performance. We are leaving it entirely to the concrete producer to choose any blend of materials that can give you that performance. I don't care how much cement you have. I don't care what water cement ratio you're using. I only want you to produce a material that will give me the required properties. You go to an electrical shop to buy a bulb. You don't give them prescriptions, right? This bulb should work between temperatures of -40 and +40. It should produce orange light of this much lumens or whatever. You have the wattage, you just say, okay, I want 100-watt bulb, so this guy puts in a socket. If it glows, you buy it. That's performance. That's exactly what we are seeing. We are seeing the performance of the concrete by specifying these numbers. The issue comes when, let's say at 28 days, you test the permeability. It doesn't meet the specification. The spec says at 28 days, you need to have a permeability of maximum so much. But you tested it at 28 days, it's not there. What do? That's when the performance specification starts becoming a problem. Just like for strength, right? We test cubes for strength. At 28 days, if the cube strength is not appropriate, what do? The structure is already being constructed. The structure is already in place. Your cubes were cast alongside the main concrete casting, stored in ideal conditions. We took the cubes out at 28 days. The strength was not enough. What do you do now? We have to do the analysis of the concrete and the structure, right? We do sometimes non-destructive testing. We sometimes take cores, right, to assess whether the concrete in the structure is also reflective of what was there in the cube. Okay, so that's the check that we do with strength. With durability, it again gets a little bit more complicated. Okay, so implementation is not always going to be very easy, but there are ways around it, which I'll talk about a little bit later. So again, in performance, the emphasis is on requirements of the finished product. That is the desired outcomes of construction, defining these outcomes clearly in terms of measurable performance criteria. Measurable. So when you say cover depth, you should prescribe a method to measure the cover depth also. These days, of course, cover meters are available. They are fairly okay. I'm not saying they are 100% accurate. They're fairly all right. But you need to have, obviously, the expertise to utilize these kinds of equipment, or at least call experts who can do that. Okay. On the other hand, prescriptive specs are just giving you a prescription that use this, you're probably going to solve the problem. Just like when the doctor prescribes medicines. The doctor doesn't know that the medicine will perfectly work for your problem, but it's a educated guess based on the experience and the knowledge of the doctor that they prescribe certain medicines, and most often it seems to be okay. Okay, I'm not going to define. So NRMCA, the National Ready Mix Concrete Association in the US, had a performance, prescriptive to performance, P2P program, which really set the tone for a lot of the work that was done in the US. That this was actually in the early part of the 2000s. So between 2000 and 2010 is when they did a lot of work on this performance specifications. So the idea that they want to say is that the performance should be framed in terms of acceptable reliability or probability of the structure performing satisfactorily. Now, where does probabilistic design come? When we do structural design, we do probabilistic design, right? We are not 100% certain that the loads are going to be this much. We are not 100% certain that the resistance offered by the structure is going to be this much. We have some confidence based on the statistical analysis, and we do some probabilistic design to ensure that we have at least 95% confidence that the resistance will be better than the demand, right? In this case, similarly, when we look at durability criteria, we have to have that idea about probabilistic estimation. You can't have a deterministic estimation of a quality of concrete that is going to be highly variable in different parts of the structure. Okay, I'll come back to this point because it's very critical to address the issue of performance. Now, the challenges in specifying performance are that you need to understand deterioration mechanisms. We're designing a structure in Calicut as compared to designing a structure in Munnar. The environment is totally different, right? The ways in which concrete deterioration can happen are quite different. In Calicut, close to the coast, obviously chloride deterioration will dominate. In Munnar, you're fairly far away from the coast, but there are other problems. There are a lot of rainfall is there, periods of drying and wetting, right? Humidities can sometimes get very low, but many times they are very high, right? So more water related problems can be there. So you need to understand what is it that you're designing for. That's why you need to understand deterioration mechanism. Let's go further inland into Bangalore. None of these problems will happen, but you have a problem of atmospheric carbon dioxide. We know that carbon dioxide penetrating into reinforced concrete can ultimately lead to corrosion of the steel, right? So that's where again you need to address very clearly what is it that you're designing your concrete for? What is the deterioration mechanism that is going to be working in your particular environment? Now, we are not complicating the strategy. Actually, the current approach is when you do the prescriptions, you are adopting a very conservative approach. Sometimes that puts some chains on us in that we are not going to be innovative with our designs to really utilize the best potential of these materials. That's where we want to move forward in trying to actually utilize the concepts that are available to us of understanding deterioration mechanisms and utilizing it appropriately. Transport mechanisms. What do I mean by transport mechanism? Transport of liquids and gases into concrete can happen through various means. If the concrete is dry and you put it in a wet soil, it will soak the water in the soil. How will it soak? It will soak by capillary absorption. If you put the same dry concrete into a swimming pool, there will be water pressure on the concrete. So there will be water pressure which will drive water into the concrete. So that's called permeation, right? You have learned these concepts in your sciences, right? Capillary absorption versus permeation, hydraulic permeability, right? So all of those concepts are quite similarly applied to concrete also. But we need to understand in what ways is the deteriorating agent, let's say chloride, in what way is a chloride going to enter the concrete? Does it have to be dissolved in water and then only by permeation can it go in? Or are there other mechanisms? With chloride or other ionic species, we also know that there are mechanisms like diffusion. The concentration of chlorides in seawater is very high as compared to concentration of chlorides into the concrete. So by diffusion, these chlorides will start moving into the concrete, right? The concrete itself can be either wet or saturated or dry or partially dry. Okay, so what happens now is you have a complicated set of mechanisms by which fluid transport into concrete actually happens. Why is this important? As civil engineers, why are we concerned? This looks more like research. We are concerned because each of these transport mechanisms is addressed by a specific test method. When we test water absorption, right? How do we test water absorption? We take concrete and dry it in an oven. We drive out all the water from the concrete and then we immerse it in water for 24 hours and measure the amount of water that is getting into the concrete. We wipe the surface dry, so saturated mass of the concrete we measure and we get the water absorption. Now, if I take the same dry concrete and put it in a tray which has some water and water only rises by capillary absorption, the result is going to be quite different from what I got in the water absorption test. But for a foundation that is sitting in soil where periodic drying and wetting can happen because of water table going up and down, versus the column that is standing in the water in a lake or a sea, the mechanism by which this water is getting in is different. So we need to use the right test method to address the transport mechanism. So once we have the test method, we have to identify what are the durability parameters I can get out of these test methods. And how do we use that now in the design? How do we use that in the performance spec to control the quality of the concrete? So those are the aspects that we really need to worry about. And there's a lot that we need to do to get there. So again, just to give you the snapshot of the performance specification process, you have the inputs where the deterioration mode is important. Exposure environment is important. Like if you look at the current IS 456 regime that we have, it's very simplistic. It does not even address the problems of, say, carbonation, right? It only talks about chloride exposure to some extent, and it talks about some general environment of exposure and sulfate. It does not really address the other important ways in which concrete can actually get deteriorated. So identification of appropriate exposure environment is important. Selection of measurable parameters. What is it that you want to measure? Absorption, capillary absorption, diffusion, all of those things need to be looked at. And we need to consider possible range of binder types. So these days, of course, special cements are not easily available. No? Many of you may have had that problem. You are working in an area where the soil is rich in sulfate. The spec says sulfate resistant cement, but it's not available. Cement companies cannot produce special cements very easily, right? Because it totally affects their production capability. So for them, it makes sense to produce consistently OPC, whether it be 43 grade or 53 grade. What do we do in case special cements are not available? We have to start looking at combinations of cementitious binders like fly ash or slag or silica fume or metacoil and so on and so forth. Today we have these combinations available which will give you the performance that you require like a special cement. The outputs basically from a performance specification process are the limiting values considering environment and binder type. For instance, let's say in Calicut, when chloride diffusion is the governing mechanism, the performance specification says that your concrete should have a diffusion coefficient of less than so much. Just to give you an example, in Mumbai, they are building this Mumbai coastal road, and they are also building the Trans Harbour Tunnel, right? Which is basically exposed to seawater environment. So there they have now specified in their construction contract that the concrete that is designed for this purpose should have a certain level of migration coefficient. Migration is another test method which is similar to a diffusion. It is done with electrical potential and so on. So that test method needs to be followed and the concrete has to specify a particular characteristic there. So that's the limiting value that is required to ascertain the quality of the concrete. Now, checking on the quality of construction. How many clients will allow this? Okay, just to give an example, NTPC, right? National Thermal Power Corporation, whenever they are building new power plant structures, it's mandated that after the structure like a turbo generator foundation is completed, the construction contractor has to go in and do ultrasonic pulse velocity testing to ascertain that the concrete has been compacted well and so on. So they have to do NDT to ascertain that all the structural elements are perfectly sound. So that's a spec that has been built in. Code doesn't say that you have to do this, but the spec says you check the quality of the construction. Similarly, you can also put in regulations with respect to the cover measurement. Okay. So clear instructions regarding non-compliance with specification. And this is where a lot of the problems happen. What do we do? Your cover should have been 50, but it's only 40. What do? You just stick more concrete on top? That's not effective, obviously, right? What happens when we are ascertaining that the concrete strength in the structure is less than what it was designed for? Let's say we designed for M30, right? But in the structure, we've ascertained that the strength is only 25 MPa. What do we do? We go back to the designers to see whether the structure is still okay right? That with respect to strength, mostly the structure is fine because we usually over design with respect to strength. So 25 MPa structure may be okay, where actual strength was 30 MPa desired. But that doesn't mean that you let the contractor go scot-free. Obviously, there have to be some penalty clauses. Similarly, for durability, right? If you achieve durability better than what is specified, you can bring in bonus clauses. If the durability specified or achieved is less than that specified, then you bring in penalty clauses. So there are ways to address this issue. But then again, one has to gain confidence in utilizing this approach. Okay? So that's where it's still sticky, but that's something that we can learn by experience and work through. So advantages of performance specifications: it accounts for material complexity, does not pose limitations for supplementary cementing materials like fly ash or slag. If you look at your IS 456, it says that you can use fly ash or slag, but it should be limited to the quantity that is prescribed for the PPC or the PSC. In PPC, you can't use more than 35% replacement by fly ash. Now you are applying the same to concrete. But the problem now is, if you really want to achieve the best property out of fly ash based concrete, like low heat of hydration for massive concrete structures like rafts or dams, if you want really the heat to be low, your substitution level with fly ash should be at least 50%. So if you follow strictly IS 456, you're not going to be using 50% fly ash, right? So that's where the spec has to be a little bit more innovative, allow for performance rather than for prescription. Durability is measured directly, sometimes in as-built structure, which accounts for process parameters also. Now this is only going to happen when the client and the contractor are both together in the game, right? In India, generally the client never trusts the contractor. That's why people like us have to get in sometimes. The contractors, I've seen, at least ULCCS has so many qualified personnel, but the client would rather listen to somebody from a university or an IIT to make a decision rather than listen to the counsel of the people who are well qualified and well trained. It's not the same in the Western countries. Why do we have to be so distrustful of the contractor? Now, obviously contractor has to make a profit, otherwise why would they be in the game, right? But then still, as long as the processes are well defined, as long as the work is being done with the right quality, there is no reason to start suspecting that they are out to do something wrong. So that's the reason why a lot of times the client and the contractor are not on the same page. But for performance specifications to work, that's an important criterion. Before this happens, you need to have a conference between the people who are involved, the client, the contractor, and if the contractor has a separate concrete producer, they also need to be brought in. That's where the discussion has to take place as to how best we can monitor the structure, what kind of qualities should we monitor on the structure, for what do we need to make cubes, and the other way out, which is being done in several countries, including South Africa, from where we really built up this collaboration on durability specifications. What they do is the National Highway Authority in South Africa, which is called SANRAL, they, wherever in projects where they employ performance specifications, they say that alongside the main structure, like a bridge or whatever, the contractor should also produce a panel, let's say a slab or a wall panel, which is subjected to the same curing conditions as the concrete in the actual structure. And from time to time, they need to actually pull out cores from this panel or from the slab and a certain durability in that panel or core. And that has to meet a particular requirement. Now, obviously, you have to make sure that you account for the variability. When you put a cube in the lab and take a sample out of the cube, it's going to be very less variable, right? It's going to be of consistent quality. In regular day-to-day construction, the samples that you pull out of your panel may have a lot of variability. You have to accept that to some extent, right? And there will be a difference between what you put in the lab and what is there in the field. You have to accept that difference. So your IS strength criteria also are similar, no? In the lab, you need to attain at least FCK plus sigma into 1.65, right? But in the field, it's not like that. It says it's okay if Average is FCK plus 0.825 times sigma or FCK plus 4, with no individual result being less than FCK minus 3. That's acceptance criteria on the site. That acceptance criteria comes because site concrete can never be as consistent as laboratory concrete. So same concept needs to be applied in durability also. The challenge is in strength, the level of variation between specimens is not very large typically. In durability, the level of variation can be significantly large, very large. In fact, we have done a round robin test across different labs in the country where we found that in some durability testing, like the one common one is the water penetration under pressure, right? Where you apply a 5 bar pressure and measure the depth of water penetration into the concrete. That is a common test now in most construction projects. There we saw that the result could be as much as 50% different for the same concrete. 50%, up to 50% difference can be obtained in that result. So you need to be aware of the extent of variability that comes in. There's better allocation of risk and responsibility when all the partners are well clear about what their roles are in this entire process. The negatives, of course, are very difficult to get agreement on suitable tests. One person wants to use one test, other person has a different test. For a long time, this rapid chloride permeability test, RCPT, right, which we also use today extensively, this has been extremely popular amongst everybody in the world. Now, if you really get into the science of this test, it is not really measuring anything useful, truly speaking, okay? Although I have myself used it in all my projects, but truly speaking, it's not measuring anything quantitative. It's only measuring a qualitative indicator of concrete performance. That test was actually popularized by the company that used to make silica fume, Elchem Microsilica. Many of you may be familiar with this product. The company which probably I think came into being in 80s, at that time silica fume was just getting pushed into the market, and they found that in this test, silica fume gave a massive advantage. Okay, doesn't mean that it performs as well in other durability tests, but in this test, the performance of course, silica fume concrete is better than OPC concrete. That's not a problem. But what I'm saying is the performance difference that you got in the RCPT was significantly higher than any other test. So these guys kept popularizing the test. That test found its way into all specifications, all job site codes. Everybody started using it. And today there's hardly anybody who does not use it. Okay. So, but then once people started realizing, okay, this test has limitations, then there was demand for doing other kinds of tests. So there can be a lack of agreement sometimes between what test to actually choose. That's where our understanding of concrete technology and the transport mechanisms becomes paramount. Lack of guidance typically available in prescriptive specs. So prescriptive specs tell you, okay, it's easy to catch somebody, no? I told you 360 kilograms of cement, but you have not put that much. But in performance, what do? You are somewhat at a loss. Lack of understanding to deal with failures, that's the primary issue. Okay. Again, we need to build in a system for that. Okay, I'll skip this. Yeah, just to give you examples of specs with durability requirements. So RCPT, as I said, is very commonly used. In North America, it's almost used everywhere, right? So this is a New Brunswick draft specification for bridges. RCPT is prescribed as 1000 coulombs without corrosion inhibitor and 1500 coulombs with corrosion inhibitor. Now, why did they say this? Now, again, for this, we need to understand what is going into the concrete when we start using materials like corrosion inhibitor. Most corrosion inhibitors are based on calcium nitrate. So when you put this in water, there's dissociation. You produce calcium ions and nitrite ions. And when you put ions in water, what happens to the conductivity? Conductivity goes up, right? Water conducts when you have ionic species dissolved in water. So more conductivity means more charge will be passed in the rapid chloride test. That's why they permit that, okay, if you're using corrosion inhibitor, you are permitted a higher number for RCPT. Similarly, they have shrinkage. They define the shrinkage at a particular age, okay? Because shrinkage keeps on evolving with time. It does not stay constant. It evolves with time. Shrinkage, concrete continuously dries and continuously shrinks. But then you have to ensure that if you're using it as a performance spec, you have to specify a particular age at which you measure shrinkage. Calgary City high performance concrete spec says that less than 600 coulombs has to be achieved in RCPT test. But they also say that, okay, let's say you don't make the 600, you go to the next stage, 600 to 1200, you pay a penalty. Now, what would the contractor do? They'll design their mix to ensure that they don't get that penalty. They design it well enough to be within this 600 coulomb margin. Port Authority of New York and New Jersey, RCPT, again, for pre-qualification, less than 1000 coulombs. What do you mean by pre-qualification? You have a concrete mix. Before the actual production, you show it to the client that it's working. So in that, they say 1000 coulombs. But the same concrete, when you're taking it to the site and doing production, they are allowing so much variability. They say that less than 1500 coulombs is okay, and that too in 80% of the tests. So 20% can fail also, no problem, but at least ensure that much. Okay, so that accounts for variability, and it also gives you a target which is slightly different from what you got in the lab. Because again, please remember, lab conditions are ideal conditions. You cannot get performance in the lab in the field. It's not going to happen. I'll give you an example from a construction project that happened in Chennai some time back. There was this Chennai port to Madurai oil elevated corridor that was being constructed by Soma. Of course, because of change of governments, that project got shelved and Soma ended up folding. They lost all their money, unfortunately. So in that project, interestingly, the columns that were designed, they had specification for rapid chloride penetrability test. And they had specified less than 1000 coulomb. But the spec also said that you have to use only OPC. No fly ash, no slag. This is a column that is standing in Kuam River. Okay, Kuam, those of you who know Kuam River, it's possibly got everything except water. Okay, so much ionic species in it, so much things can come in through Kuam into the concrete that will get deteriorated very fast. So, okay, they've used RCPT spec, but they say that no cement can be, no other blending material can be used, you have to use only OPC. Now, everybody knows that unless you use PPC or PSC or some blending material along with OPC, you cannot bring down your RCPT value significantly unless you choose a very high grade of concrete. Your structural demand is only for M45. But with plain OPC, you'll have to design it to M60 or M70 to get that same level of 1000 coulomb performance. Why would I waste my money in designing concrete which is over-designed for strength just to achieve this durability? So these guys did an interesting thing. They said we'll use fly ash, but not as a replacement for cement. We'll replace sand with fly ash. They replaced up to 10% of the sand with fly ash. Lo and behold, they got their results and they didn't upset the client. Okay, but see, this happened because the client again was too conservative in their approach. And that's one of the problems that we have, conservativeness of clients. There's a lack of understanding of how concrete would change when you move from OPC to blended cements. Just to put on record, in my opinion, if tomorrow there were no OPC, I would be very happy. Because we can get all performance in concrete with PPC or PSC. We don't need OPC at all. Okay? So those of you who are writing specifications, who are structural designers, who are making these specs, please make sure don't prescribe OPC. We can get a lot more performance. And today, actually, it's not right from the point of view of sustainability to use 100% OPC. Why? Because OPC is responsible for, or production of cement is responsible for nearly 8% of global carbon dioxide emissions. And just imagine if you're substituting 30% of the cement with, let's say, fly ash, which is a waste from thermal power industry, you are automatically cutting down that much of CO2. So you're doing a great service by utilizing blended cements. So today, using OPC is not a good idea from the point of view of global CO2 emissions. Okay. So again, that's one of the strongest arguments in line with using blended cements. Now the issue there is obviously that one has to understand how concrete will behave when blended cements are used. A lot of the residential customers, they got upset when OPC was taken out and PPC was prescribed because they found their strengths were not getting achieved at the same cement contents. But all you have to do is redesign your concrete. Ultimately, concrete has to perform. It's not the cement that performs. The concrete has to perform. Your choice of content of cement and water binder ratio ultimately leads you to the concrete performance. And that's what you need to design for. So a lot of the people, consumers in the market seem to think it's a cement. And cement companies have also created that image, right? That this cement is stronger than that cement. No, that's not correct. It's the concrete that has the strength. It's not the cement. Even lay persons also call the concrete road as a cement road, right? They always say this is a cement road. You can never make anything with cement. You have to make it with concrete. The concrete has to be designed for performance, not the cement. So what we did in India, we came together, several of us across different academic institutions as well as practicing engineers. We came together to work on a committee in ICI and produced this handbook, durability handbook. This was brought out in 2019. And I think this year there is a plan for doing some workshops in different cities to popularize the contents of this book. It's basically talking about in detail what I'm trying to present to you in this 1 hour. Okay? So again, most of these things are covered quite nicely in this book. Of course, it's only a primer. It's not intended to be a one-stop solution for everything in durability. It's available from Indian Concrete Institute for purchase if you want a book. But I think if you want to download, it is available hopefully for free. We've been trying to convince them to give it to everybody for free. But the printed version, I think you need to pay some 750 rupees or something like that. Right, so as I said, you need to identify the exposure classes correctly. What we have to do is look at how we can alter this in the standards. So I'm just giving some examples here. For instance, there was a paper by Vijay Kulkarni in 2009 which talked about how we can identify different deterioration mechanisms and give prescriptions for the environmental classifications to be used in this case. Another example here, this was some work that was done by one of my students, master's students, who was actually a candidate from CPWD. So he was able to provide a lot of data about CPWD concretes used in different construction projects. And we saw how we could have actually altered those to make them fit better into the new scheme of classification as far as environment is concerned. So again, here, this is prescription. This is not performance. This is all prescription. But the idea is that you identify environments appropriately. Okay. So again, coast, if you look at IS 456, it says coastal construction. But how long is the coast? How far do you consider as a coastal environment? So that was the idea here, that coastal environment definition should only apply up to about 10 kilometers. Beyond that, the influence of this airborne chlorides that come from the seawater is not going to be significant. So beyond 10 kilometers, you can start looking at the inland conditions, 10 to 50 and beyond 50. Your requirement for the concrete need not be as stringent as it is close to the coast. But within the coastal condition, you have the seawater exposure classes where you have water that concrete that is completely immersed or concrete in the spray or tidal zone. If you look at our IS 456 classification, we have severe, very severe, and extreme. Severe is completely immersed. Very severe is which is subjected to airborne spray, and extreme is when you have this tidal and spray action, tidal action happening in the concrete, like a column that is in seawater. So here what we have done is combined the spray and tidal into one category because it's very confusing. Otherwise you have a column in seawater, right? What do you consider? Do you consider the extreme condition or very severe condition? Because part of it is outside. So you can't apply the different exposure environments to the same structural element, right? Or even in one building, you have to actually choose the same exposure environment. You can't apply different exposure environments. So in this case, we sort of simplified this a little bit further. So prescriptions are going to remain with us. We're not going to completely avoid prescriptions. But what we should do is identify the particular deterioration mechanisms and then give prescriptions for the same. I'm happy this presentation can be shared with everyone, so you don't have to bother about taking pictures which may not be clear. Okay, so performance specs should be adopted. Okay, I'm stating here the handbook. So where is performance specification required? Wherever we have critical national and state level infrastructure, for instance, bridges, metro rails, tunnels, viaducts, warehouses, industrial establishments, and large commercial and residential housing complexes. Now, in such cases, we want some level of durability. Now, when you build a house, do you look at how durable it should be? How long should it last? What is your idea when you build your own house? How long should it last? 50 years? 50 years is rather high. It should last. When does a normal average person build a house? What age? 30, 35 if you're getting rich fast. Most people would build around 45 to 50, right? Most people would build their houses around 45 to 50. So in that age, your expected service life for the human is how much? After another 30, 35 years max. So that's what you want to build the house for, because house is your dream, right? You build the house to your specifications. Your children may not like that kind of a spec. So in 30 years down the line, your children may want to demolish and reconstruct as per their specifications, right? So 30, 35 years, conventional practices, prescriptions, they seem to work okay. But if you really want maintenance-free service life, what do you have to do? Just like you look after your body by exercising, eating the right kind of foods and all that, you get maintenance-free service life, right? Structure also same thing. Oftentimes, from time to time, you need to stop the leakages, you need to paint the house, right? All of those things you need to do to get the maintenance-free service life from your house. But when you start designing bridges, they are expected to last for at least 100 years, if not more. Today, monuments are being built where we want design life of 150 years, 500 years, 1,000 years these days also. There's no clear practice with which we can do 500 or 1,000 year design life easily. There are ways in which we can estimate some things, but nobody lived that long to identify what's happening. Anyway, so durability has to be looked at carefully in these kinds of projects. So again, test protocol has to be good. To achieve durability in construction, test protocol has to be good. Raw material testing all the way up to concrete testing. All this has to be done well in advance, and you have to put together a scheme of doing the tests, the kind of standards to be followed, and what happens in case of non-compliance. All this has to be identified and looked at the beginning of the project itself. That solves a lot of problems. You bring in the client also, get their confidence and ensure that you're able to follow this. Right? For instance, the Ayodhya temple, right? The foundation basically, so L&T is doing the construction. They took our help to do the concrete foundation. So there we again did the same kind of practice. We ensured that each and every material test was very clearly specified, because of course it's a plain concrete structure, no steel. That's why 1,000-year design life. But even to get there without deterioration of concrete, they need to make sure that they're using the right materials and the right proportion of concrete and so on and so forth. So that's the idea, that you do this at the beginning of the project so that people don't have any questions about it as you go along. You need to define the tests on concrete carefully. Now, appropriate durability tests also need to be specified, right? So again, here you need to ensure that your initial testing work including durability testing, has to be completed and correlationships established if necessary between different test parameters, okay? So what does this mean overall? This means that if I have to put concrete tomorrow, I should have started my mix design at least 3-4 months ago. But you've all seen construction projects. If I have to put concrete tomorrow, I get only 1 day for doing the design. My materials are available, people are ready to put concrete on the site. The design process, nobody gives you time for. That's one thing that needs to be emphasized very clearly. You cannot produce concrete, which is what today a lot of people use the term bespoke, right? Bespoke. That means tailor-made for particular conditions. You can't produce bespoke concrete unless you have at least 3 months to do the design process. 28 days is enough to do the strength, but how do you know that you'll get your concrete mix right on day 1? You may have to still play around. If you're doing performance specifications, there are shrinkage, permeability conditions that need to be satisfied. You need to have some time to evaluate a range of options. Minimum 3 months, preferably 6 months. Ideal case, Everything ideal, 1 year. Why? Why 1 year? Okay, source changes could also be there. Yeah, that if you start evaluating all that, it will take longer. But more importantly, properties like creep and shrinkage. If you're building a high-rise structure, those kinds of properties become very important. Creep and shrinkage becomes extremely important. Now, creep and shrinkage, nobody can test for you in 28 days and give you a result. That result doesn't hold anything. No sense at all in that. Creep and shrinkage have to be tested minimum for 6 months and ideally for at least a year. Okay, there are scientists in Europe that have tested creep and shrinkage for 40 years for concretes. Can you imagine? All the basic work that really has helped in production of our design approaches and models, they've been working for 40, 50 years. So that's the time that you need to really do a good design. Okay, so I wanted to emphasize that concrete has to be looked at carefully. You can't be ready for it the next day. Right. One very important problem that comes when durability testing is done is the sampling frequency. How often do you sample for strength? It's there in the codes. Right? Every 50 cubic meter, you take one sample. One sample means 3 cubes. Right? And I think there are some more frequencies that are described very clearly for strength. You can't do the same with durability. Each durability test will take you a long time. Each test takes minimum of 12 hours. If you're just doing resistivity measurement, you can do it immediately, no problem. But all these chloride-based tests, at least 12 hours, if not 18 or 24 hours. So you need that much time. So obviously, you have to define a frequency of sampling for testing, right? So this is just a recommendation in this code. It's not something that needs to be followed, but yes, you can use this in case you don't have a clear idea. Conformity assessment. Again, we can't specify a single value, but also be aware of the kind of variability that can be expected in the test method. The other problem is third-party testing. The laboratory that does these tests has to be properly trained and qualified to produce the result that is indicative of the concrete quality. Now, this is sometimes very difficult in our country. We don't find very high-quality labs across the country. I'm very happy to see that the MatterLab has been opened here, and they've already gotten themselves certified. And we need more such labs across the country to really do this kind of work, because these tests need a proper understanding of the concrete material and how the durability tests actually affect or get affected by the qualities of these materials. So make sure that this has to be addressed in a much larger way. Testing on constructed elements, cover meter survey, ideal to do it, may not always be permitted. But again, it's all a question of bringing this into the specification, right? Electrical resistivity is a very interesting test. It's a portable device. As long as your concrete is completely saturated, it will give you a fairly reliable result. So, and electrical resistivity is quite nicely interlinked with the durability of the concrete with respect to its corrosion performance. The higher the resistivity, the lower is the risk of corrosion. Okay, so if you produce concrete which has greater resistivity, you are likely to have a more durable concrete structure. And this resistivity test has been actually utilized for field control of concrete quality also. In the new Suez Canal construction, there was a Spanish agency that did the evaluation of the concrete, and they used electrical resistivity to evaluate the concrete quality. Right, so before the construction starts, you need to plan for durability. Again, all of these things will come in there. I think I'll probably just quickly stop with this. Modeling, again, is a much later stage once you start getting confidence in all of these test results and are able to utilize the results properly. I'll not go through this. I just wanted to show you that to produce all of these ideas, you need to have the background in terms of testing a large variety of materials. And you need to generate databases. That's where the laboratories across the country need to come together and generate these databases for our understanding of what happens when you use blended cements instead of OPC. For instance, this was a study we did with Lafarge-Holcim some time back, but we did a study over a range of durability test methods. So this was the challenge that we were trying to do, identification of durability parameters and test methods. We had several different concretes that we did in this study. All these results are well published, so I can always direct you to the right publications to show you the results. So we have several different methods to assess chloride permeability, assess gas penetrability, like carbonation, oxygen permeability, and so on. We also did water penetration and water penetration under pressure, as well as water sorptivity test, and of course the concrete resistivity test. So all of these were done on a range of concrete mixtures just to show the extent of change in durability indices when we start replacing cement with fly ash or slag. That was the idea here. I'm not going to go through the results in more detail. What it basically tells you is that your mineral additives are extremely beneficial in a chloride induced corrosion environment and may produce some difficulties in a carbonation environment. Okay, you have to take both sides of the story. But just to give you an example, what can we do with this kind of a thing? So if you look at the environmental classification proposed by the British standards, which is a adopted version of the EN specifications, again with seawater they have 3 different categories, and if you really look at prescribing the condition or fixing the performance characteristics in all of these by addressing the particular transport mechanisms that actually occur in these environments, then you can fix these numbers and make sure that your concrete basically satisfies all of these characteristics. So this is what we did from the database that we generated, and we found that this was a fairly good approach in designing concrete not just for strength but also for durability for a particular environmental classification. Okay, yeah, I'll skip this. So ultimately, to really employ performance specs, you have to follow a step-by-step process. It's very important to ensure that you do pre-qualification tests, which are on cubes that are stored in ideal conditions, but you also do tests on the site. One simple way on the site, instead of even creating a panel, is to store your cubes along with your structure. Store your cubes along with the structure and test those cubes rather than cubes that are stored in the lab. Just for getting some sense of how the variability is, maybe you can start doing that in some of your construction projects. That will be very important data for you also, to look at the variability, to look at the understanding of how things are different near the structure in ideal conditions, right? So that you can start doing on your own basis also. And then you need to have acceptance criteria, as I said, taking into account variability of the durability testing, and decide on either a bonus or a penalty clause in terms of satisfaction. You can pay or not satisfied. You can say the job contract or the spec has to clearly specify what happens in case this is not satisfied. Right. So I think I'll stop with that. Performance approaches give a rational means of durability design, gives a quantitative meaning to service life. We are not just shooting in the air. We have some definite target for which we are building the structure. Innovation in materials and technology is encouraged because we now have potential to maximize usage of supplementary materials, but implementation still poses challenges which we have to overcome by gaining confidence by applying this in small ways. Several projects in India have now started implementing. Of course, they have their prescriptions. But several projects have started implementing durability testing as an important part of the overall project. That's a step in the right direction. What we need to do is take that data that has been generated from all these projects and plow it back into new concrete design to see what we need to do to get that combination right, strength and durability. Should we always over-design the strength to achieve durability? That's not a right approach. Sustainability wise, that doesn't make sense. If only 30 MPa is desired, why should I design 45 MPa concrete? It's not giving me any advantage, right? Can I design durability at 30 MPa? Yes, I can. That's where my mineral admixtures come in. So our results also went to show that even for residential concrete, where you typically do M25, if you're lucky, sometimes M20, in those cases also, you can utilize mineral additives to actually improve durability significantly, right? So thank you all very much. I'm happy to interact. As I said, we have a TLC2 week where we are talking about, of course, durability is one of the primary things, but we are also talking about several other things about minimizing waste in construction. I've given some ideas about how to register for this TLC2 week. TLC2 is Technologies for Low Carbon and Lean Construction. That's a new center of excellence at IIT Madras. and it involves faculty mainly from our materials and management group. So we are addressing this issue of prolonging structures, minimizing waste in new construction, also reutilizing a lot of the waste that is generated from construction projects, especially construction and demolition waste. Thank you. Thank you very much. Yeah.
Thank you, Manu sir. Now, let us move directly to the audience. You may please share your queries. And before that, please tell your name and organization and share your queries. Please.
Also, I'm very happy to say that many of the people who have actually worked on all the durability spec projects are based in Kerala, like Dr. Jayachandran from NIT Calicut. We have Dr. Elson John who's at MA College, and there's also Dr. Dhanya who's at RIT Kottayam. We have a very large network of PhD students from our group who have actually taken up academic positions in Kerala. So you have all the information available on anything about durability specs.
Hi, sir. This is Jibish here from MatterLab, sir. So my question is like, if we are using steel fibers, like in concrete, so will this RCPT test give the appropriate results, or do we have any alternative for that?
Yeah. Okay. Yeah. When you use steel fibers, the conductivity of the concrete is going to go up significantly. So RCPT will not work. It will produce. It will show as if your concrete is of poor quality, because steel will conduct the electricity, the charge. So you don't want to use RCPT. You may want to use some test which does not include electrical potential. Like a water absorption test or a water sorptivity test is fairly good. No, somebody had. Yes, sir. Sir. Okay. So about 15 years back, space of 650 square feet was built with one-story building construct Chennai at the cost of 6.5 to 7 lakhs, using newly bonded system as binders. I'm not very sure about this building, sir. Okay. House does not have plastering on the outer surface. Okay. Okay, I'm not very sure what binder was used, sir, in this case. Sir, no, correct, sir. So we are looking at a lot of alternative materials, not just fly ash and slag. We are looking at other possibilities also. But the thing is, of course, you need to address the life cycle. You can't just look at how the effect on the initial strength and so on. You may have an effect on the life cycle. Overall durability, how is it affected, and so on. Which one, sir? What? TMT. Okay. Okay, sir. Sure. Sir. Okay. About Joshimat. Okay. But this is more related to this thing, sir. How the ground has subsided because of the increased level of construction. Yeah. But that I'm not very sure where the durability came into picture here. But mostly it's related to the seismic events after ground subsidence. Maybe Dr. Srithi may be able to answer your question better, because he's a geotech expert, sir. Thank you. Yeah. Yes.
Hi, good morning. Professor Manu Sundhanam for giving a nice presentation here. I am attending, I think, third presentation of yours on the same subject.
Okay.
Okay.
So that means I've talked enough about it in Kerala.
Yeah, no, I heard a lot about it. Here, just want to make a statement. Okay, I will introduce myself. I am Shyam Kumar, Head of Ready Mix, Uralangal, ULCCS. I would like to tell you that as a society, as a construction company, we are into performance-based concrete in an indirect way. You know, there are a lot of prescriptive specification here, but we make sure that we use a blended cement in most of our project. I can say that we are doing something like 35,000 cubic meter a month in Kerala right now. We are doing approximately 80 to 90 percentage
With
blended cements. Okay, even though the local, even though the government or PWD specifications ask for OPC, and they are not insisting sometimes for blended cements, we have we made sure that we are going with blended cement. There is a project called Chellanam where we do the protection of seawall. All the tetrapod is done with PSC. And the NH66, the first phase, where we are using PSC cement for all construction. I think we started using PSC so that many of other stretches, they start converting it into PSC. Okay, so, and we thanks to our consultant for the support also they have given to us. Here I have a request to you. Okay, there is a project from Arur to Thuravur, which is an elevated highway. I think 300,000 cubic meter concrete is there. One of my friend is associated with that, and he called me up to ask me what should be the minimum cement, water cement ratio for piling mix. I will just quote this. More specification which is being followed all over India, right? IRC specification is there for pile construction, but Morth is the one, the Bible, which everybody follows, right? There is a typographical error, okay, which I pointed out to Morth maybe few months back, to I think in May, last May.
Okay.
I never got an answer. So I want your support to write down to them. They may not hear people like me, but they may hear you. So the thing is this, section 1104.2, concrete in piles, table 11001 states that minimum water cement ratio should be 0.4.
Minimum?
Yes.
Oh.
I pointed it out, but IRC 78 2014 709.1.9 page 33 states maximum water cement ratio. So we followed that. We convinced our consultant, and they, these gentlemen, they accepted it.
Correct.
But the guy from Arur, it's 300,000 cubic meter concrete. And there, I think maybe a few thousand cubic meters of piling is there. They're going to do it with minimum 0.40 water cement ratio.
Not a good idea.
So, no, this can be happening. If the consultant is adamant, people have to follow. So when I do 50, M45 or M50, I need to unnecessarily increase the cement content. So we are talking about net zero carbon emission and all, a lot of discussions are happening. But in practice, it's not happening. So this is a big mistake. Some consultant, as you said before in your presentation, they insist for that. They will say, no, we cannot change it. It is more specification. So I need your support to write down to them. I'll share you these clauses.
Certainly.
Okay, I'm going to meet you at 5 o'clock in MatterLab.
Sure.
So I'll be sharing it with you. I need your support.
Yeah, I'll be happy to.
Thank you very much.
Thank you.
Thank you, sir. Thank you for sharing your valuable knowledge. Thank you, Manu, sir. Moving on to the next talk of the day. We have yet another eminent speaker, all the way from Guwahati, Dr. Srideep S. Dr. Srideep S. is currently a professor in the Geotechnical Engineering Division, Department of Civil Engineering, Indian Institute of Technology, Guwahati. He obtained his PhD and MTech degree from IIT Bombay and BTech degree from Calicut University. His research interests include behavioral studies of unsaturated geomaterials, hazardous waste management, utilization of waste materials, and biogeotechnology. He has published more than 100 technical papers in international and national journals. He was a recipient of the Shemshir Prakash Research Award for Geotechnical Engineering in 2014. He is a member of ASC, ASTM, IASC MAG, IGS, and TC 106 of ISS MGE. With all respect, I invite Dr. Srideep S. for his technical session. Sir.
A very good afternoon to all of you. Before starting my talk, I would like to first of all thank ULCCS and MatterLab for inviting me and giving me this opportunity to participate in their inaugural session of their Tech Talk series. In fact, it gives me immense pleasure that such a novel initiative in the form of MatterLab has taken place, because we were wondering, like, there are immense opportunity for such a lab, but we didn't find any with such an initiative. So this is I really wish like MatterLab be a where it becomes a supportive environment for many of the constructions and the infrastructure development that happens. I'm also happy to note that generally these Tech Talk series is conducted by academia. So I think this is the first time like when such a lab or maybe a construction based infrastructure firm is organizing. Is a very welcome move, and I think more would follow in the days to come. So I'll be talking about geo-environmental engineering towards sustainable development goals and relevant to Kerala. Even though I have stated it is context to Kerala because I'm giving the talk here, the concepts that we'll be discussing, it's universally applicable. I mean to say the projects and the problems remains the same, and it's applicable elsewhere also. So let us first start with the definition of geo-environment, because generally when I say geo-environmental engineering, uh, people take to like mostly it gives an impression that it's only about waste management. I would like to slightly differ from that and say that wherever soil interfaces with the environment, there are several lot of problems that deals with such issues. So to give a glimpse of what are the possible problems, it may look like these problems are all known to us, like what is so new and why we should be discussing. In fact, that is true. uh, Many of the aspects we know, and many of the problems also we know, but now a time has come that there has to be a conscious intervention to find solution to those problems, because now time is getting delayed. I would give you a good example, or maybe a small example. Maybe 35 40 years ago, um, I was young during that time. We were playing a lot. We just go and take water from the pipeline directly. We never bothered whether it is good or bad, or whether it's going to upset our stomach or whatever. But can we think? We can't think of that right now. We never heard the concept of filters maybe 30 40 years before, but we can't afford to live without filters in the household these days. So that is a classic example, and all of us know this. But there has to be a conscious intervention in the days to come, so that our future generation also enjoys the benefits that we have enjoyed. So that is the whole purpose of this particular lecture. So this is about the geo environment, where we talk about the interface between the atmosphere and the unsaturated soil. I hope the pointer is not working. Pointer working. Okay, okay, fine, fine. Okay. So we are generally talking about this soil atmosphere interaction. Again, this problem is not new, but then it is time for us to understand in a very logical manner to find solution to certain problems which we'll be discussing in the following slides. We talk a lot about climate change, global warming, extreme weather conditions, sea level rising, drought and flooding. Again, these were never subject of discussion maybe a few years back. I'm talking about maybe 20, 30 years back. Even though it has started, it was not very relevant or it was not very visible. But now, every instance reminds us like it is time for us to consider such time bombs, I would say. So, the primary impact of these generally happens on the very important resource which is soil. There's a direct impact. Here you can see the most important aspect. For example, if it's global warming and extreme weather, maybe temperature, it influences the soil moisture. We, as such, we don't realize how important it is to preserve soil moisture because there's a lot more. Because it's somehow similar to our human body. Many functionalities that goes inside we don't realize, but that is very much essential. It's more or less similar to that. Like in the case of soil, soil moisture plays a very important role in the it determines and it has some influence for the local climate even. So temperature, it influences the soil moisture loss. Soil moisture loss in turn influences the kind of temperature that evolves. So it's a vicious circle. And it also influences the soil quality, like the biological activity that happens. Now, again, there's something which we as engineers think that it may not be that important, but then when we see a holistic picture, it is definitely it is important. Yeah, again, Kerala is a water-rich state. We we understand, but then there are enough evidences that prove to say that if we are not careful, in the days to come, we will be in a dire shortage of water. So this is again an important natural resources which need a specific attention from an engineered perspective. So water scarcity, the kind of artificial recharge of aquifers. Now, we cannot rely on surface water all the time. And Kerala has a good reserve of aquifers. Now, the kind of groundwater usage and the groundwater depletion is at an alarming scale. So, a conscious effort to do water conservation in terms of artificial recharge, water preparedness is something that is important. What I'm talking about is these are some of the aspects that comes as an interface with the soil and which is relevant to geo-environmental engineering. Then comes the effect of the extreme weather in terms of drought, if it is flooding in terms of erosion, nutrient loss and increased soil salinity. This we have seen, 2018 flooding that has happened followed by 2019. There were a lot of news in the discussion, like immediately after flooding there was a long temperature spell and this accelerates the process of erosion. Now again, these are all known facts, but then it is time for us to think about for preserving the soil reserve. Now a lot of movements have taken place globally, if you have seen, like conscious efforts for preserving soil as well as water. Another big issue which is faced these days in India as well as abroad is wildfire. Again, it has something to do with the extreme weather and the drought condition. I said that soil moisture plays a very important role. Now, when there is some changes in this, it obviously leads to such conditions like wildfire, followed by because of this extreme temperature, soil is generally not hydrophobic, but when we subject it to high temperature, it becomes hydrophobic. Again, that becomes a reason for water repellency as well as erosion. Now, everybody talks about waste and its impact on the environment. So, again, it's not a kind of an engineering project worth investing. So, we tend to always ignore the waste management aspect very badly, but that is basically the reason why we are in such situation where we cannot rely on the water that we are drinking, and it definitely needs engineering treatment. So then it follows, like, where the geo-environmental engineering becomes important is to assess how much is the impact of such waste on the environment, and what need to be done in order to prevent this or mitigate this. Essentially, we talk about these impacts on land degradation. Okay, so the second important terminology is about sustainability. So when I started reading sustainability, I was always confused. What actually does it mean for engineers? So just I was reading through, because it's an important buzzword in today's socio-economic and political world. So I was just trying to read through what sustainability is. Again, I'm not going to read this. I was not able to follow much by what the actual definition of sustainability states. There are a couple of such definitions: capacity of Earth, biospheres, and human civilization to coexist. Essentially, what it means is that we need to use the resources very responsibly, so that we reserve some of them for the future generation as well. So that's the actual thing, what I understood what sustainability is all about. But then that's not really, that's not completely taking care of what engineers should look forward for when it comes to sustainability. And more importantly, I noticed that sustainability definitions are domain specific. We need to tailor make it so that things doesn't violate the primary requirements, for example, engineering. Society, economy, environment, political, cultural, technological, and it's an interplay of all these. So it becomes slightly complicated in understanding what actually is sustainability when it comes to practice. So when I say modern sustainability, it all started off with this particular commission, Bertland Commission in 1983. It's based on United Nations World Commission, because I'm coming to this because the United Nations has set some 17 sustainability development goals. So it's just the background of that. So Bertland Commission's first volume, Our Common Future, this was released in 1987. So this was the time when sustainability has started gaining a lot of importance. And in every stream, it is there. So let's talk a bit on what does sustainability mean for engineers. So I'll just talk, before getting into the details, let's see what are the three pillars of sustainable development. It's economic growth, environmental protection, and social equality. So this is how it looks like, and it clearly shows what is the subset of the other. And according to this figure, it's very clear that what dictates sustainability is environment, and this is where the whole importance comes in. Now let's try to map this for engineering requirements. Now, for engineering requirements, we have certain parameters, certain ranges that we are looking for. Now, most of the time, this cannot be achieved if we completely rely on this particular definition. So that is where I said sustainability to some extent will be domain specific. So economy is a subsystem of society, which is already explained in this figure. The three pillars are interdependent, and mostly the sustainable developments is bound by environmental protection. The gain is the loss of the other. So it means that coexistence of all the three, it's very difficult to achieve, even though we aim for that. So those are certain limitations which is applicable for some engineering projects. So without defined targets, sustainable development is an unfocused term. So it's very good to speak what is sustainability, but when it comes to practice, it is indeed difficult. And indeed difficult, especially for engineers to meet the targets. So actually, what is the real definition for sustainability for engineers? Engineered planning, design, and application confirms to society, economy, society, and the environment. So here, and economy and society will automatically be met, but what about environment? So we start with what happens to environment. So nowadays, it's a mandate that all of the DPRs do address this particular aspect of environmental impact assessment. So it has become a very important theme of any major projects. Then there is another aspect of it, that polluters must pay, but I don't think that such a requirement will ever get implemented in country like India. I'm talking this in general. Energy, material input, output are safe. Again, that is a very important concern. Like what goes in and what comes out, it should not impact, or it should not create problem to the environment too much. Adopting to green technologies. This is a very important area of research these days, where we talk about green manufacturing, green chemistry, and so on. So there's a lot of work going all around to keep as green as possible. And focusing on renewables, that everybody knows these days. Similarly, for society, achieving the need of larger population. And positive long-term impact. So again, Professor Manu was talking about what about the long term. So that is all. Earlier days we never talked about such long-term impacts, but now time has come that we even look at what is the long-term impact, which is in a way very difficult to quantify. We need to have some out-of-the-box solutions based on short-term understanding that you project it for long-term. So that is where all these data science, artificial intelligence, the new machine learning models can play a role. But again, those are not going to solve all the purpose, because these all needs ample amount of data. And that is the most important challenge that we face. Health and well-being. Okay, so that's a part of it. Similarly, economy. Now, this is a very important aspect that is talked about these days. Circular economy. Like what goes in comes out, and it doesn't create too much of a burden to the environment. So this is an important concept which many of the industries are trying to adopt and follow. So following that, minimizing waste is one of the very important aspects, how better it can be done. Closed cycles of operation, which indeed refer to the first one. Life cycle cost benefit analysis. Again, these were never talked about in the past, but then a lot of importance has been given to all these in the present day. So these factors are all interrelated. So to be very specific for geotechnical engineering, because this civil engineering or maybe geotechnical engineering is very close to society and the economic well-being. Roads, buildings, and how to minimize the impact of this on the environment. Improving design guidelines to improve the resilience towards frequent disasters. Now again, a very important branch of engineering these days is how to develop resilience for the newer constructions, which again we never considered in the past. The resilient construction, more tolerance to disasters, because now we see that the frequency of extreme events like high intensity rainfall followed by drought, there's a huge variation, and this is going to add a lot of stress on the construction. So extreme precipitation, flooding, drought, cyclones, wildfires, landslides, mud flow. It's a long list now. And if you see many of these AC reports, American Society of Civil Engineering, a lot of such reports which comes up every day. Uh, I'm not seen many with relevant to India, but there is a huge conscious effort from American Society of Civil Engineering towards these, because now they have understood that most of the natural resources like water and soil is terribly under stress. So I think the soon we will also follow suit, and we will also have to make a conscious effort in this. Here, sustainability means the requirement of less interference in the sustenance of an which is a very explicit understanding. Disaster resilient infrastructures is the focus of research these days. And geotechnical engineering is the first step of any construction, starting from the site selection. So when we say resilience, we also need to see that how resilient that particular site is for a given construction. So it becomes a wholesome understanding even in terms of climate of that particular area. And this is very important for all major projects. For example, if an airport is going to come up, we need to take up all these into consideration, which was never considered in the past. How to optimize the design and maintain balance between sustainability and risk reliability. And this is the focus for the coming generation. Life cycle, again, I have already talked about it. How much impact does it create? Now, to be very specific to geo-environmental engineering, because when it comes to geotechnical, things are pretty clear. But when it comes to geo-environmental, it is very close to nature. We are talking about the various aspects of soil behavior. Not only the engineering behavior. That's what I mean to add here. Because when we consider geo-environmental, there's a lot of other factors and parameters of the soil which we need to consider. Again, these are all normal definitions. Let's see how does it actually, how it is important. So we generally talk about soil and water. Soil means the porous media. It includes even the rocks. So soil as a building material, because we consider soil as in two different ways. One is like it is a load bearing material, and it is also a building material. So conservation of this becomes an important aspect. Now, how do we conserve? We need to find alternate materials. Now, alternate materials is a subject of research which is widely talked about these days in all fields of infrastructure development. Similarly, subsurface and surface water resources, again, it's time for a conscious conservation. Agroforest and food security, again, this with all these climate change impact, extreme weather condition, this also becomes a very important aspect to be considered. It's followed by very large scale urbanization and industrialization that's going on all around the world. I remember when I joined IIT Guwahati in 2006, the situations were not that urbanized. But today in 2022, it's exponential growth, which means to say, we can't avoid it, but then which means to say the soaking power of the earth is drastically reducing. Because if we are really talking about the kind of extreme events like high intensity rainfall, the data says that such high intensity rainfalls were also there in the past, even in 1920s. But the only thing that has happened is the soaking power of the land. And this needs a conscious intervention now. There are several concepts which people talk about, like sponge cities in China. It is a hugely urbanized location, but now they are trying to do it in an engineered manner where more water is getting soaked in an engineered manner, so that that temporary surge of flooding effect is considerably reduced. So it's time for us, because when the rainy season comes, almost all the cities face the same problem. Like at least temporarily, traffic is disrupted. We are not able to move from place to place, all because of flooding. and resources for energy. So pollution, land degradation, desertification, water quality, greenhouse gases, and climate change becomes an important aspect of today's research. So containment, I mean containment of waste properly. When it comes to solid waste, we are not that concerned and we do an indiscriminate disposal. But when it comes to hazardous waste, industrial waste, there has to be a proper engineered containment. We don't get to see this in Kerala too much, maybe because the kind of waste to be contained in terms of hazardous nature is not that much. Most of the disposal are surface dumps. Remediation means the one which got polluted. Is it possible for us to dispose it off, or we can derive some useful materials and remediate it? Water conservation, I've already talked about. Renewables, the concept of reduce, reuse, recycle, and recover. So I'll just now touch upon the next aspect. So we have discussed about what geo-environment and what sustainability means in terms of geo-environmental engineering. So I'll just touch upon some of the sustainable development goals. There are 17 sustainable development goals which United Nations has laid out, which the focus is that we achieve it by 2030. And a lot of discussion to take place whether we'll be able to achieve this or not. That's always a debatable aspect. So some of the sustainable development goals which may be relevant to geo-environmental engineering would be the second one, that is zero hunger, good health and well-being, clean water and sanitation, industry, innovation and infrastructure, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land. So see, these are some of the important sustainable development goals where water, soil, waste management plays a vital role in the realization of these selected some. There are other goals as well where it may not be exactly relevant to geotechnical, geo-environmental engineering. So the practice in geotechnical, geo-environmental engineering can, I would not say always it is possible, but some conscious measures would definitely contribute towards achieving these goals. So some of the problems which are context to Kerala, but I would again like to repeat, it is a general problem, but there are certain few things which becomes very specific. I just happened to read this. Tourism, Kerala listed 13th among 52 must visit tourist destinations in 2023 all around the world by New York Times. Kerala, the only state from India. So this is something a very important aspect. Why? Because tourism, we need to take care of many other aspects as well. Yes, Kerala was a very important agrarian state. I would not say that it is still, but it is still considered as agrarian state. But we have a lot of food materials that gets imported from other states. So it is still having that agrarian ecosystem, not to that extent that it was in the past. Tea cultivation, coconut or coir industry, food packaging industry, medicinal herbs, agri-waste management. These are some of the important aspects for Kerala. Beach, coastal erosion mitigation, restoration and protection. The need for nature-based solution. And when it comes to nature-based solution, we are not talking about anything new. It's more like old wine in a new bottle, where our ancestors, our past people, they have immensely practiced all this. But what has happened is in between, somewhere we have forgotten or maybe forgone those aspects. So now it is important, like we come back to our roots and seek more of nature-based solution, especially in these situations where it can be implemented. Restoration, protection of rivers, backwaters, lakes, ponds, wetlands, and sacred groves. Because Kerala was rich in all of these. And in India, elsewhere, there are many conscious efforts where a riverfront is getting protected. Earlier it was not. Now a lot of infrastructural development in terms of river restoration is going on all around the world. So I'm sure a similar kind of practice will have to be soon started in Kerala as well, because we have rich river resources, and the protection of river we cannot adopt to all the conventional construction schemes, because that's going to be quite costly. So we need to have again a hybrid solution where we talk about partly nature and partly the constructed materials. So all of this becomes very specific for Kerala. Stability of hills, mountain ranges, preservation of heritage structures. With all the rainy seasons these days, it's quite common in news about the landslides that happens all around. Now, it is an after effect of the kind of constructions that has, and the kind of urbanization that's happening. So along with construction, we also need to have ways and means to protect these slopes as well. Again, the question is it rewarding worth investing? So we need to change that mindset, and I'm sure the construction firms like ULCCS and MatterLab would not ever compromise on such aspects of construction. Design life of dams. Again, Professor Manu was talking about how much should be the design life of buildings. The same, like there's a lot of inconsistency in the way we perceive what is design life, especially for dams at least. We expect a lot more than for what it is designed from what we see, because the kind of decommissioning procedure and the kind of construction of new dams prevents us from doing so. But then this is a subject of very important matter, because most of the dams are aging. So at least we have to think in terms of rehabilitation of the dams in a more engineered manner, and for that we need a very sophisticated methods of destructive or non-destructive testing. I mean destructive means to some extent, but more of non-destructive testing to understand the health. So we call it health monitoring of structures. It is widely practiced in core structures, but then same is applicable for any other infrastructure as well. So this becomes a very important aspect: design life, safety, rehabilitation. Excessive soil and groundwater pollution and the associated remediation. Waste management, surface dumps, landfill, biomining. So all of this comes very relevant for Kerala as well. Frequent occurrence of natural disasters, we have already discussed about it. So I'll just touch upon three important aspects, which is water conservation, soil conservation, because these are natural resources which need to be conserved, and waste management. So these three aspects becomes important. Preserving usable water for present and future, and Kerala is no exception. When we have a lot of natural resources at our disposal, we never think about its importance. So slowly we are forced to think as things goes bad. So time to act, protect rich water resources, maximize water use efficiency in agricultural sector, because every drop saved is important. So revive historical methods of water conservation. So a lot of such movements are now going on all around the country. A very good example would be some of the very important projects that has happened in Telangana, because they have tried to revive all the very conventional system of water conservation these days, and it is paying off well in terms of its. So similar kind of things we also have to, because we are receiving a huge amount of water every rainy season, but are we able to tap it properly? Are we able to reroute it to the aquifers? This is a question to be addressed. Replenishing vast aquifers, that's what I meant. Preservation, rehabilitation of rivers, ponds, tanks, step wells, and wetlands. All of these are there very much in, at least I can say that a lot of these exist in Kerala. Only thing is it need to be revived. Engineered intervention to tap flood water and make it to usable water. The concepts of green roof, green infrastructure, sponge city concept. Again, all of these are new terminologies, but there is nothing new into it. We have been practicing this since old age days, but then again, we have forgone it somewhere. So it is time for us to revive all these. So engineered intervention to convert waste water to potable water. Now this may be important not basically for places like Kerala, but then there are certain places where they face intense shortage of water, maybe in the desert environment. So every drop of water, now there are technologies where highly unusable or the wastewater can be converted to potable water, but yes, cost becomes an important constraint. So the research has to be focused in such a manner we use hybrid technologies and make it cost effective. Soil amendment and optimizing irrigation for arid regions. Again, this may not be very important for Kerala, but then if you are planning for engineered agriculture, for example, in the case of greenhouses, now poly houses or greenhouses becomes an important initiative towards cash crops production. So it offers a lot of possibility even for the startups, and those are happening. So in those situations, we can always save water by using suitable amendments. I'm just sharing an example of such a research where we try to optimize the irrigation under drought condition. So basically, we try to develop certain soil amendments which can improve water retention and store more water in the soil. I mean to say, like you irrigate or when the rainfall occurs, the amendment material, it can hold more water, which can be useful during dry spells. So improving drought resistance of soil is a way to improve sustainability in irrigation. So this is a map which shows about like the orange portion is marked as drought hit region. So we think that India, the drought problem is not much, but that's not true. Major part of India, in fact, is affected by drought. So the focus of research is how to improve sustainability in water retention and water storage. So I'll just skip this because these are some of the reasons resulting in hydrological drought, low water holding capacity of the soil. Again, it has something to do with the temperature even. So as I told in the beginning, it can reduce the water holding capacity. Migration of water into deeper layers. Now, when you water it, not all the water stays in the root zone. It migrates down. So the focus of research is how to hold it for some time. So excess runoff, again, that's a part of the irrigation. Improper management of water resources and poor irrigation system. So deforestation and degradation adds to it. A possible solution is basically applicable for arid regions where we need to cultivate. So it's called application of water absorbing material as soil amendment. In fact, this material again, it's not new. It has started well off, and it's called super absorbent hydrogels, which is even used very popularly in even concrete as well to address the shrinkage issues. So here we have termed it as water absorbing polymer, or in general it is called hydrogel. And hydrogel has got very wide applications in many fields of engineering, starting from medical to engineering. So it can absorb and retain huge amount of water. So we try this water absorbing polymer, we can prepare it, or we can synthesize it from some of the waste materials. So what we did is we tried to use fly ash as one particular product for making this water absorbing polymer, because fly ash, a lot of the burden of utilizing such waste materials has been taken by concrete industry, but still there's huge amount of fly ash that is left unused. So we still need to find alternate use of these fly ash in mass quantity. So that prompted us to see whether we can transform what non-water absorbing material like fly ash to a water absorbing material. To some extent, we were successful and we could synthesize water absorbing polymer from fly ash. Then naturally the question comes into picture, like what about the leaching of some of the heavy metals present in fly ash? In fact, to add to that point, all these chemical components becomes toxic when it is beyond a certain quantity or concentration. So fly ash is otherwise also advised as fertilizer in specific quantity. So there are guidelines for using that. So for these type of applications, we are using even less than that. So the leaching problem and the environmental impact is almost negligible. So these are the some of the results. I would not again go into that, just to show like it was working fine, and this is the kind of gel it forms after it interacts with water. So next we'll just touch upon soil conservation and management. Changes to soil resources, it is explicit example of global warming, drought, desertification, and high intensity rainfall, two extremes that the soil has to be protected from. So it's an interaction of both. The climate change impacts soil, and soil in fact impact what is the kind of climate, the local climate that it forms, even though we don't realize that. So high temperature, drought, desiccation, it's not ideal for soil quality. And most important is soil moisture. The pattern of soil moisture has correlation with precipitation pattern even. That was proved in some of the studies. Soil moisture precipitation correlation, it is dependent on several other factors as well. And loss of soil moisture, it negatively impacts the soil carbon storage, land quality, and bioactivity, to name a few. Another important aspect is erosion. We are losing most of the fertile soils, and all of this is getting settled down in seas. So, and in the reservoirs to some extent. So we need to have a conscious effort to prevent or to mitigate erosion. Now, most of the aspect related to soil erosion, it was from agricultural point of view, where we talk about loose soils. But equally important is many of the constructed infrastructure, for example, embankments, where the soils are compacted. Now, we have seen that the models that we use for predicting erosion or obtaining the characteristics, it's not really valid for compacted system, which we generally use in geotechnical engineering. Another important aspect is cracking and desiccation because of alternate wetting, drying, because all this, it contributes to further erosion and deterioration of the soil quantity. Now, another important aspect of climate change, which is widely discussed, is this increase in sea level rise. Now, how that is going to impact the soil resources, because in coastal regions, and which is very well relevant for Kerala, the soil salinity increases, which in fact it is contaminating, and this makes it less productive in terms of agriculture. So this is what I talked about. We just did some analysis, and this work was basically for soil covers for hazardous waste. Essentially for, it was a BARC project where they wanted to create covers for their waste disposal facility. So now at that point of time, we realized that the erosion characteristics that we generally talk about is not actually applicable for a compacted system like this. So this was some of the experiments which we did to revise what is existing related to erosion models and how does it play well for the compacted system. So again, I don't have to discuss that in detail. This was a controlled experiments that we performed. So some of the erosion models like revised universal soil loss equation, it was found that it is not predicting it well for compacted system, and certain modifications we did to take that into account. Again, because of paucity of time, I'll not go into the details. Now, in the context of all this, one emerging branch of, I would say, geo-environmental engineering is biogeotechnics and some of the new perspectives where we talk about soil plant atmosphere interaction. Now, if we go for nature-based solution, this becomes an important aspect. And this is very important for de-desertification. Now, we may think like whether such a thing is possible or not. Yes, indeed it is. And such projects are happening very well in China because there's a huge initiative to de-desertify a particular region. Same is applicable for urban green infrastructure, bioengineered slope, which is a lot is given in today's world in infrastructure development. Slope protection, whether we like it or not, it is always specified to go for nature-based or vegetation for protection of the slope. Again, biopolymer for improving soil water storage. I have already discussed this. Biochar for soil amendment. Again, this transforming some of the waste to char and use it as soil amendment. In one way, what happens is we are adding value to the agri waste and we are also earning carbon credit in terms of carbon fixation. Again, something which is very well discussed these days. And improved soil retention, soil nutrient retention and bioactivity. It also increases soil water retention. So these kind of topics are gaining a lot of research in today's world. These are some of the examples where we talk about soil root composites for cover system, urban agriculture. Now something, a new terminology has come up because we find that it's only structures and structures, so a conscious intervention in terms of urban infrastructure. So similarly, that is applicable for landfills, green roofs, and bioretention system. So the last part is about waste management. Again, I don't have to explain much. We know that when water interacts with the waste, it finds its way to the groundwater resources. This is what I was talking about, surface dumps and engineered landfill. So this is a common picture that we find in today's world, mostly all over. And this is an engineered landfill, which is mostly practiced for hazardous waste in our country. Again, this requires a conscious intervention of engineering principles for finding of to retain or to contain the waste. So this is about the typical waste dumps. You can see that rainwater comes, the surface water gets generated. Finally, the net result is pollution of surface and groundwater. Why I'm discussing this is because now there is a new concept to revive these waste dumps. So closure issues of open dump site, it is never done in a controlled manner and hence a lot of issues happens. So this is a serious issue which need to be sorted out. So now there are mandates that has been given in order to handle these open dump sites. So guidelines for handling open dump sites are not well defined. This is equally important for a state like Kerala as well. No control of waste deposition and no temporary covers. There will be significant issue of slope stability due to steep piles of waste, risk of fire, greenhouse gas emission. All of these are happening now also, but maybe we are not realizing to that extent. No guidelines on the closure of dump site. So what best need to be done? So we'll go to that particular solution. So this is a new concept that has come in, what is known as biomining, which is a sustainable practice to manage surface dumps. So it's the process of extraction of these huge waste, segregation, and then trying to use it. So according to the statistics, it is around 3,000 dump yards with 1,300 million tons of, this is called legacy waste because it is stored on the ground, and a lot of some 10,000 odd hectares of land is occupying in the urban space. Now the thing is how to revive this site and make it usable. So complete recovery of dumping site, that is the focus these days and the mandate put forth by Government of India. So reduce future groundwater contamination. So biomine material include secondary resources, combustible materials, and large volume of fine fraction. Around 50 to 70 percentage, it is called soil-like material, SLM, and necessitates a thorough characterization. Since this is relatively new, we don't know much about this soil-like material. So how to make it usable further? Because ultimately this need to be reused somewhere. So that is a challenging research problem to be addressed. So establish leaching of SLM to assets. Basically we need to understand its environmental impact. Use it as fill material. Now, a lot of characterization need to be done before using it as a fill material. Again, that depends upon the physico-chemical properties. Some of these are given here, and other utility of the reclaimed materials. And the leftover materials has to be scientifically disposed. So one problem should not create the other. So it has to be a holistic exercise. So reutilization of reclaimed land. Now this land was under such huge heap of waste. What happens to the property of that particular land also need to be addressed. Now this is a different aspect which is very much important in today's world, where geotechnical geoenvironmental monitoring and its instrumentation. Essentially, the earlier speakers were already touched upon, Pandeyji has discussed about the importance of drone survey. Now this is very important even in the planning stage, execution, even in disaster management when it comes to geotechnical engineering. For landslides, rock falls, debris flow, so it becomes quite handy because most of these sites are inaccessible. So such technologies becomes quite important for, again, these are some of the examples. I would not get into the details. The drainage pattern of an area is extremely important when it comes to the stability of such geotechnical infrastructure. Discontinuity mapping in terms of surface cracks and joints, very important for rocks. If you want to really understand the stability of rocks, we need to understand the discontinuity pattern and understand what will be the strength that it offers. The only way is we manually do this currently. Now such technologies can be used for doing. Similarly, there are a lot of applications of electromagnetic sensors when it comes to soil monitoring. So these are some of this, where we measure the negative water potential of soil. I discussed about soil plant atmosphere interaction. Such type of monitoring is very much important. Even for controlled irrigation scheduling, this is important. Similarly, how much is the water content present in the soil becomes very important for some of the, even for landslide early warning system. This is very widely used. Both these becomes an important tool when it comes to landslide monitoring and early warning system. So need for dedicated R&D for developing such indigenous sensors, because now most of it are imported and we have to pay a lot of price. In fact, a lot of research is needed whether we can develop these indigenously. Okay, let me summarize this. Like, a very important aspect which comes out of today's discussion is to find out a sustainable or alternate materials, because now, as I said, soil is an important resource. So wherever we can save soil for infrastructure development, we should be dealing with new era of geomaterials replacing soil. And one of the important possibility is the reutility of waste materials. Even recent Niti Aayog meetings, they have specifically stated on this particular aspect of how to use the waste materials, and Bureau of Indian Standards have come up with very important guidelines related to this, and they do permit the use of waste materials into construction. Similarly, there are some of the important aspects related to soil geomaterial, biomaterial composite and its interaction, which has its impact on urban forest, bioengineered slope, drought management, soil water conservation, and minimizing erosion. So the way forward, these are some of the points which I thought will summarize. Revisit and redefine atmosphere, soil, plant, water, nutrient interaction, because this is very specific for low maintenance bioengineered infrastructure. Degradation kinetics of biomaterial, which was never talked about in the past. Life cycle cost benefit analysis becomes a very important aspect when we introduce such alternate materials. Develop flood and drought resilient geotechnical infrastructure, because this is what is going to be affected primarily. Instrumentation and monitoring becomes a very important aspect, and mathematical modeling, considering the uncertainties, what Professor Manu also touched upon. So this also becomes a very important aspect. I'll just sum up stating this because MatterLab is a new initiative, because there are several other very good examples which we can quote, and where the technology intervention can be effectively made by such laboratories or research organization. So reliable laboratory testing facility to support all the infrastructure development activities. Development of field testing or maybe non-destructive geophysical investigation. These are very specific and very special testing procedures, and we don't get expertise all the time. So it will be really a welcome move from organizations like MatterLab to gain expertise over a period of time. It's not going to be done in one go, but certain aspects like geophysical investigation is the need of the hour. So that becomes very important. Mobile labs for agriculture. Soil health assessment is a very important aspect in current Indian conditions. So forming a bridge between government and expert panels for specific technical input. Now, sitting in academia, I've always faced this problem, like getting into the roots becomes difficult, and the ULCCS kind of organization or the MatterLab, you are into that. So you can effectively bridge this gap between academia and the practicing or maybe government organizations when it comes to a project development. So develop consulting wing for specific jobs related to maybe natural disaster, beach, river front restoration, water conservation. Some examples. So there can be a specific consulting wing that can be developed, because once that is done, then it is like projects after projects will come to this specific organization. Focus on waste management, reuse, because this offers a lot of possibility in the days to come. And of course, a lot being talked about in terms of renewable energy. So some of the examples, there is a very important example where Norwegian Geotechnical Institute, they also started in a very humble manner, but then the kind of projects that they are dealing all around the world, it is magnanimous. So a great model to emulate and develop. It's an independent center, and that independence is very important. Like there should not be too much of interventions from outside. So the lab or the research organization, they should be independent for research and international consultancy. Sophisticated and well-established laboratory and field characterization of soils and rocks. They practice conventional geotechnology. Along with that, now they are into waste management and mining, looking at the possibilities. Energy, offshore and onshore, disaster management, instrumentation and geospatial analysis, climate impact on geostructures, risk and vulnerabilities. But all these, it was not started off in one go. It was all developed. They have a huge legacy. It's an old institute. So all these were improved and it was developed over a period of time. So it's an important example that can be emulated. Same is the case with United States Salinity Laboratory. It was established in 1947, and now a lot of projects being done for government and others in terms of watershed management, soil management, sustainable agriculture. These days it is smart agriculture, and so plant genomics, they are even into that. Food security becomes an important aspect. So what I mean to say is there are ample examples which one can cite where such labs have been started and they became the pillar or maybe the strength of various government and societies for looking at various infrastructure problems. Thank you.
Thank you, Srideep sir. Now to the audience, please share your queries.
Good afternoon, all of you. I am Ishwaramurthy, Corporate Manager, Environment, Health and Safety, ULCCS. First of all, thank you, Dr. Srideep, for an excellent presentation on this. And everybody enjoyed it. Actually, normally, a session before lunch period, keeping the people intact, it will be very difficult. As a trainer, I know it very well. So you did very excellently, and I watched everybody was with you. Okay, thank you. Thank you for the excellent session. And we are in the heart of God's own land. Neela Akasam, Pachakadal, Swarna Bhumi. So it's a beautiful state in the entire India. And you are in the northern eastern part of India, and we are in Kerala.
Very similar to Kerala.
Yes, I know. That's why I'm coming to that only. Okay. Sustainability is very difficult to achieve and practice. That's what you mentioned in your slides. As a EHS person, I'm facing the same heat while implementing my responsibilities. But nowadays, I can see a lot of improvement from, for example, the projects, in the projects what we are working with now. One of our projects, Alappa Changanacheri project, it's a KSTP project, and it's a World Bank aided project.
Yeah.
So some 10 days back, there was an audit from the World Bank team. So they mainly concentrated on environmental aspects, and thanks to our entire team, we came out with flying colors in that audit because of our commitment towards environment, and we have satisfied them, and they appreciated us. It is one of the best projects with the KSTP. Okay, the main my question is I don't have any major question to you. My main issue is we are not effectively implementing the legislation requirements in India.
Yeah.
So you know very well. In India, the first EPA Act was implemented only in 1986, aftermath of this Bhopal disaster in 1984. So when it was implemented in 1986, after that there were some minor changes. But during 2019, the present government, they made a lot of changes, and that revision still under abeyance because of political reasons and opposition parties, and there were a lot of issues. So when that will be implemented, do you have any idea on that?
Absolutely not, because again, I told you, when it comes to practice of sustainability, I am not the correct person, because I understand it from all these perspectives.
Yes.
But when it comes to ground reality and practice,
Yes.
I think I cannot comment much on that. The answer to that you have already told.
Yes.
Partly.
Yeah.
And for the same reason, but I'm sure in the days to come, this has to be implemented, and it will be implemented in some form or the other better than today.
Yeah. So for example, initially you told, those days we used to drink water from the river directly.
Yes.
Nowadays we are using filters. But those days we are healthy.
Yes.
Nowadays we are not healthy.
Yes.
Yeah, same thing. So the sustainability is a big question. And as you mentioned, you clearly mentioned, polluters must pay.
Yeah.
They have to be punished.
Legislation again.
Yes. Legislation has to be implemented effectively.
Yeah.
Then only we can sustain.
Correct.
Thank you.
Thank you. Thanks a lot.
Dr. Srideep, just sorry.
I am Matthew,
Yes.
a structural engineer.
Okay.
You have given a good exposure to the society-soil relationship. Thank you very much.
Thank you.
But in reference to that, I want to ask you one thing. In reference to the recent continuous floods in Kerala, there is a remark that the carrying capacity of the Kerala rivers are reduced because of the ban on sand mining in Kerala rivers. Your opinion on this?
Yeah, it's an important environmental concern. You mean to say because of sand mining, the carrying capacity? Uh, I would, yeah, I would suggest like more than that, there is an issue because of sand mining. I would consider it more problematic for the stability of the river system itself than the carrying capacity. So I would see this as a major geotechnical problem when it comes to sorry, the sand mining. You're creating more space, so the water flow increases and it creates a lot of stress on the banks, and it even changes the course of the river. I mean to say, the tendency to change. So that creates a lot of stress on that. But this is a major problem, and not only that, we have a lot of reservoirs. Now, majority of these reservoirs are is losing its water storing capacity because of the sedimentation problem. Now, how to dredge it out, how to use this, it's a matter of research elsewhere, but I don't know whether such an initiative has started in our country to that extent. So this is something very important which need to be considered, because we are just losing the space for water to be stored. So again, all of this are connected problems. Against sand mining, I don't have a clear, I would say, data to explain to the manner which you have asked. But this is my general understanding. For me, it is more like a stability problem. No, yes, in fact, the riverfront restoration work essentially means this, like it is stable, at least in that, and it invites a lot of tourism potential as well. It's a very good example. I have visited myself Sabarmati, and the same thing is going on elsewhere also, because in Badrinath, where the conditions are even worse, a lot of restoration activities are going on, and I think that's the need of the hour. And not only restoration, we also need to ensure that water that is flowing is indeed water, like what Professor Manu was also talking about, Kovai River. So it is time for us to actually think about all these, and there is a conscious governmental intervention also in the days to come. But we have to be prepared, like we need to have solutions to be offered when government comes up with such projects. So it becomes important in that perspective. Sir, you were asking.
No, I had a more technical question.
Yes,
The for the dump
surface dumps.
Yeah, surface dumps that you showed, no? You talked about soil-like matter.
Yes.
Now, has there been a proper characterization done? Is it indeed 60 to 70%?
So it is like this is not a well understood material, because the concept of biomining started off recently. So there are studies related to, and the statistics which I've shown is based on those studies. It is more like soil like material. You feel like you are dealing with soil itself after segregation. But if it has been thoroughly characterized for its utilization, it's partly. So if we want to use it as a fill material, now maybe the compressibility can become an issue. So those type of research need to be further done, and suitable amendments used so that it achieves the required character. But it's a win-win situation. You're trying to remove a huge heap, you open up the land for further utility, and at the same time, instead of soil, you use soil-like material for specific applications. So that is the advantage. Yeah. This is a very important question. Now, the thing is, we have been practicing something from the past. even if we see our own household, the most easy thing is to just throw it out. So the concept of surface dump has evolved from there, and we never talked about it till we started realizing that okay, our resources are getting badly polluted. If you see abroad, uh, the the landfill design, proper management, all of this has happened maybe 50 years ago. They have data for last 30 years coming out, like how it is performing. Again, the motivation is what is the returns. If you invest in, there are several infrastructure projects going all around India. Now the question is, what is the return that you're going to get if you invest in a project, very important project like waste management? This is not actually proven. We think that constructing a landfill, you're just dumping the money there. But there are avenues by which it can be done, but it is not very clear. So the most important motivation is profit from a given infrastructure. Sometimes you are forced to create. That is why for all hazardous waste management, landfills are created even in India. There are a lot of examples. Even for solid waste management in Bombay, there are engineered landfills. Ramki is an important company who does such activities. But mostly for hazardous and industrial waste containment, one need to go for engineered landfills. So it is there. But for municipal solid waste, like the household organic waste, we don't pay much attention. We feel that somehow soil or the earth will be able to digest all this. But the time has shown that these are in fact time bombs. So it's not actually happening. So now all these conscious effort has been made, like biomining is one of the solutions which they think may work. Yes.
And converted to manure, etc.
Yeah.
Nowadays by using various local agencies.
Yes, yes.
My question is it those methods can include under biomining process?
In fact, biomining is something like we are talking about legacy waste, the waste that has been stored over a period of time. The methods and practices which you are talking about, for example, there are many housing societies now, they are taking care of the waste management themselves. Like they are trying to create the organic waste into compost. And maybe they can do it on a commercial scale also, because it creates a lot of compost and that can be used for agriculture. So that practice is slightly different from the biomining which I talked about. Yes.
To add to that gentleman's question, I would like to say an example of landfill being converted. If you know Dubai Safari Park, which was built on top of a big landfill.
Yes.
So everyone can do that.
Correct.
Even India, it can be done. Yeah. Spaces can be utilized. Such landfills can be utilized in a different way.
Yeah.
That's one thing. You were talking about the rain intensity in your childhood, my childhood, and the same thing is happening now. There is no much difference in the intensity. Then why these floods are happening? I think a lot of studies, researches are happening here. But I just want to know, you are from Kerala. Your house is...
Yeah, I'm from Kannur.
Kannur. You have a house there. What about the premises?
Things are not different anywhere, because I face, I am one of the victim of this.
Yeah, that's okay. I'm asking about the premises. What I see all over Kerala is, which is an extended township. It's no more a village.
Correct.
You don't have villages here. All extended, townships. Any house, newly constructed house, the owner thinks about putting paving blocks around.
Yes.
Okay, and restricting and allowing sudden water flow into the road. Correct. Roads are without drainage. Roads are getting flooded. It goes fast into the river. This is my observation.
Correct,
okay.
Correct.
And that's how, I see one of the reason that the water is not penetrating into the ground. In my childhood, I used to, എൻ്റെ മുറ്റത്ത് ഒന്നുമില്ലായിരുന്നു, വെള്ളം നമുക്ക് പേപ്പർ വെള്ളം ഓടിക്കാൻ പറ്റുമായിരുന്നു. മഴ വീണ് കുറേ നേരം കൂടെ വെള്ളം കെട്ടി കിടക്കുമായിരുന്നു. There is no such things happening. So to Professor Manu Sundanam, because I am into concrete and you are also a concrete technologist, the use of no fines concrete will be helpful in this case of removing the paving blocks and bringing in such technologies, which is there since maybe 30-40 years, but bringing in such technologies, insisting, legalizing or making it a statutory requirement may help places like Kerala where there is not much difference between the hill and the sea, the water flows so fast. So it may help to retain the water. It may help the ground recharge of water. So such projects should come up. Of course, there are many negatives, cleaning of such things. There are so many negative points, but there is no such studies are happening over here. That's it.
Thank you.
Hello, sir. Thank you for your class.
Hello.
It was very nice. I am Manoj Jamke, Superintending Engineer, Mine Irrigation, Kozhikode. I am comfortable with Malayalam. Can I speak Malayalam?
Sure.
Okay. See, നമ്മളെ കേരളത്തിലെ ഏറ്റവും വലിയ ബുദ്ധിമുട്ട് ഫ്ലഡിംഗ് ആണ് ഇപ്പോൾ എല്ലാം പറഞ്ഞുകൊണ്ടിരിക്കുന്നത്. നമുക്കറിയാം നമ്മളെ വീടുകളൊക്കെ ഉള്ളത് നല്ല പറമ്പുകളും അല്ലെങ്കിൽ വയലുകളിലായിരുന്നു. പണ്ടുണ്ടായിരുന്ന തോടുകളൊന്നും ഇപ്പോൾ നിലവിലില്ല. സാർ യു ക്യാൻ അണ്ടർസ്റ്റാൻഡ് ലിറ്റിൽ ബിറ്റ് ഓക്കെ ബിക്കോസ് ഐ ആം കംഫർട്ടബിൾ വിത്ത് മലയാളം. സോ ഈ വെള്ളം മുഴുവൻ എന്താ സംഭവിക്കുന്നത് ഒന്ന് മാറ്റിയാൽ സാറേ കാണണം എനിക്ക്. അപ്പോൾ ഇതെന്താ സംഭവിക്കുന്നത് വെച്ചാൽ ഈ വെള്ളം ഒഴിച്ചു പോകുന്നില്ല. കാരണം നമ്മൾ അടുത്ത വീടുകൾ വരുമ്പോൾ ഉണ്ടായിരുന്ന തോടുകൾ നികത്തി റോഡുകളാക്കുകയും റോഡുകൾ ഇപ്പോഴുള്ള പഴയ നല്ല റോഡുകൾ ഇപ്പോൾ തോടുകളായി മാറിയിരിക്കുകയാണ്. അതാണ് അവസ്ഥ. കാരണം ഇത് വെള്ളം ഒഴുകി പോകുന്നില്ല. പണ്ടുള്ള തോടുകൾ മുഴുവനും മാറിയത് കൊണ്ട് തന്നെ ഈ തോടുകൾ നാച്ചുറൽ ഡ്രെയിനാണ്. ഇറ്റ് വാസ് ലീഡിങ് ടു ദ റിവർ. അവിടെ പോകുന്നില്ല ഇപ്പോൾ. ആ വെള്ളം അവിടെ കിടക്കുന്നു. മാത്രമല്ല നമ്മളെ വയലുകളെല്ലാം ഒരു കാലത്ത് റിസർവോറിലായിരുന്നു. ഈ വെള്ളം സാറ് പറഞ്ഞ മാതിരി നേരെ നമ്മൾ അക്യുഫറിലേക്ക് പോകുമായിരുന്നു. അത് പോകുന്നില്ല. ഇത് അവിടെ ഇവിടെ കിടന്നിട്ട് ഒലിച്ച് ഫ്ലഡിംഗ് ആയി കിടന്നിട്ട് ആരാൻ്റെ പറമ്പ് കൂടി ഒലിച്ചു പോവുകയാണ്. അപ്പം മെയിൻ പ്രശ്നം നമ്മളത്തെ തോടുകൾ നികത്തിപ്പെടുകയും ഇത് ശരിയായ രീതിയിൽ നമുക്ക് പണ്ട് വയലിൽ കെട്ടിക്കിടക്കുന്ന വെള്ളം ഇപ്പോൾ തോടിൽ കെട്ടിക്കിടക്കുക നമ്മളെ പറമ്പിൽ കെട്ടിക്കിടക്കുകയും ഈ വെള്ളം പുഴയിലേക്ക് പോകുന്നില്ല. ഇതാണ് മെയിൻ പ്രശ്നം. ഇത് കഴിഞ്ഞ് നമ്മൾ ചെല്ലുന്നത് പുഴകളിലാണ്. ഈ പുഴകളിൽ വരുന്ന ഈ വെള്ളം ഒലിച്ചു പോകുന്നില്ല എന്നുള്ളതാണ് സത്യാവസ്ഥ. അതിനുവേണ്ടിയാണ് ഇറിഗേഷൻ ഡിപ്പാർട്ട്മെൻറ്റ് കഴിഞ്ഞ വർഷം റൂം ഫോർ റിവർ എന്ന പദ്ധതിയിൽ ഉൾപ്പെടുത്തി നമ്മളെ മുഖ്യമന്ത്രിയും മറ്റു ടീമുകളൊക്കെ നമ്മൾ അവിടെ നെതർലാൻഡിൽ മറ്റു പോയിട്ട് റൂം ഫോർ റിവർ, അതായത് നമുക്ക് വെള്ളം ഒലിച്ചുകൊണ്ടിരിക്കുന്ന ഡെപ്തിലും വിടുത്തിലും പുഴകളുടെ ആഴം കൂട്ടുകയും ഒരുക്കുകയും വേണ്ടിയിരുന്നു. പക്ഷേ നമുക്ക് മെയിൻ റിവറിലേക്ക് കടക്കാൻ പറ്റില്ല. കാരണം അവിടെ മണലെടുക്കുന്ന സമയത്ത് നമുക്ക് പരിസ്ഥിതി പ്രശ്നങ്ങൾ പറഞ്ഞുകൊണ്ട് സെൻട്രൽ ഗവൺമെൻറ് അതിൻ്റെ കോൺട്രിബ്യൂഷൻ വേണം, സ്റ്റേറ്റ് ഗവൺമെൻറ് കോൺട്രിബ്യൂഷൻ വേണം. പക്ഷേ നമുക്കതിൽ പോകാൻ പറ്റില്ല, ഹൈക്കോടതി ഇടപെട്ട്. പക്ഷേ അതിൻ്റെ എല്ലാ കൈവഴികളും നമ്മൾ ഈ പ്രാവശ്യം കോടിക്കണക്കിന് രൂപയുടെ മണ്ണെടുത്ത് പുറത്തുവിട്ടിരിക്കുകയാണ്. ഇറിഗേഷൻ ഡിപ്പാർട്ട്മെൻറ്റ് ചെയ്തുകൊണ്ടിരുന്നത്. പക്ഷേ ഈ മണൽ ഇതുവരെ ഓപ്ഷൻ ചെയ്യാൻ പറ്റാത്ത അവസ്ഥയാണ് നമുക്കുള്ളത്. ഇവിടെയാണ് പ്രശ്നം. കാരണം ഈ മണലെടുക്കാൻ നമുക്ക് പറ്റുന്നില്ല, ഈ ഓപ്ഷൻ ചെയ്യാൻ പറ്റുന്നില്ല. അതുകൊണ്ട് പക്ഷേ ഇപ്പം നമുക്ക് പുഴയിലേക്ക് ഒഴുകി. അപ്പം കഴിഞ്ഞ ഈ 2021 അത് മുമ്പിലുണ്ടായിരുന്ന മഴയ്ക്കും ഫ്ലഡിങ് ഉണ്ടായിട്ടില്ല. എറണാകുളത്ത് മാത്രം ഒരു സ്ഥലത്തുണ്ടായിരുന്ന വെള്ളപ്പൊക്കം. അതുണ്ടാകാൻ കാരണം അവിടെ ചില സ്ഥലത്ത് ബ്ലോക്ക് ആക്കിയാണ്, മണ്ണെടുത്തില്ല. അത് പറ്റും. ഈ പ്രാവശ്യം അടുത്ത പ്രാവശ്യം ബ്ലോക്ക് ഉണ്ടാവില്ല. പക്ഷേ മെയിൻ പുഴയിൽ നിന്നും കൂടി നമുക്ക് എടുക്കണം. അതിന് സെൻട്രൽ ഗവൺമെൻറ്റിൻ്റെ ഒരു ഇൻ്റർവെൻഷൻ കൂടി അതിൻ്റെ ആവശ്യമാണ്. സ്റ്റേറ്റ് ഗവൺമെൻറ് ഇപ്പോൾ നമ്മൾ ചെയ്തുകൊണ്ടിരിക്കുന്നുണ്ട്. അപ്പോൾ വളരെ നല്ല രീതി നടക്കുന്നുണ്ട്. മാത്രമല്ല സാർ നേരത്തെ സംസാരിച്ചിരുന്നു, റിസർവോറിനകത്തുള്ള ഡീസിൽറ്റേഷൻ അവിടെ ഇപ്പോൾ സർവേ നടത്തിക്കൊണ്ടിരിക്കുകയാണ്. ഇപ്പം നമ്മളെ കേരള ഇറിഗേഷൻ റിസർച്ച് ബോർഡ് അവർ നടത്തിക്കൊണ്ട് പല സ്ഥലത്തും റിസർച്ച് ചെയ്ത് കഴിഞ്ഞു. ഓപ്ഷൻ പോകുന്നില്ല. കാരണം 40-50% ഓഫ് സിൽട്ടാണ്. ഇതാരെടുത്ത് പുറത്തിടാൻ വരെ ആളില്ല. അതാണ് അവസ്ഥ. അപ്പോൾ അത് നമ്മൾ എന്ത് ചെയ്യണം, ഗവൺമെൻറ്റിന് ഇനിഷ്യേറ്റീവ് ചെയ്യേണ്ടി വരും. എന്നാൽ മാത്രമേ നമുക്ക് അതിൻ്റെ സ്റ്റോറേജ് കപ്പാസിറ്റി വീണ്ടും പഴയ രീതി കൊണ്ടുവരാൻ പറ്റുള്ളൂ. അതുകൊണ്ട് റിവറിൽ നമ്മൾ വർക്ക് നടക്കുന്നുണ്ട്, സ്റ്റോറേജിൽ നമുക്ക് ഇറിഗേഷൻ്റെ എല്ലാ പരിപാടിയും നടക്കുന്നുണ്ട്. പ്രശ്നം സാറ് പറഞ്ഞാൽ ബാക്കിയുള്ള മെയിൻ പ്രശ്നം നമുക്ക് മാലിന്യമാണ്. വെള്ളത്തിൻ്റെ മാലിന്യങ്ങൾ വളരെ കൂടുതലാണ്. നമുക്ക് ഈ പ്ലാസ്റ്റിക് മാലിന്യം മറ്റങ്ങൾ കൂടാതെ അതിന് പുറമേയുള്ള സംഭവം എന്താ വെച്ച് കഴിഞ്ഞാൽ നമ്മളെ വെള്ളം ഒരൊറ്റ മഴ പെയ്താൽ 48 hours വെള്ളം നിൽക്കുന്നില്ല. ഈ വെള്ളം മുഴുവനും ഒലിച്ച് കടലിൽ പോവുകയാണ്. മാക്സിമം വെള്ളമുള്ള 3 റിവേഴ്സിലാണ്. അറിയാമല്ലോ, കബനി, പാമ്പാർ, ഒന്നുകൂടി 3 റിവർ. ഈ 3 റിവറിലാണ് മാക്സിമം വെള്ളമുള്ളത്. ഈ വെള്ളം ഒലിച്ചു പോകുന്നത് കിഴക്കോട്ടാണ്, ഇത് ഉപയോഗിക്കുന്നത് തമിഴ്നാടുമാണ്. അപ്പോൾ നമുക്ക് ഇതിനെന്ത് വേണം? തടയണകൾ നിർത്തുകയാണ്. ഇടയ്ക്കിടയ്ക്ക് തടയുണ്ടെങ്കിൽ മാത്രമേ വെള്ളം നിർത്താൻ പറ്റുള്ളൂ. അതിന് പ്രപ്പോസൽ ഇങ്ങനെ പോയിക്കൊണ്ടിരിക്കുന്നുണ്ട്. പക്ഷേ പല സാഹചര്യങ്ങൾ സാർ അവിടെ പറഞ്ഞിരുന്നു, ലെജിസ്ലേറ്റീവിൻ്റെ കുറച്ചൊരു അറ്റൻഷൻ കൂടുതൽ നമുക്കുണ്ടായിരുന്നെങ്കിൽ ഇതെല്ലാം നിൽക്കും. അതുകൊണ്ട് നമുക്ക് സ്കേഴ്സിറ്റി ഉണ്ടാകില്ല. സ്കേഴ്സിറ്റി സാറ് കാണിച്ച ഗ്രാഫിൽ കേരളത്തിൽ ഡ്രോട്ട് കാണിച്ചിട്ടില്ല. പല സ്ഥലത്തും ഇപ്പോഴും ഉണ്ട്. അപ്പോൾ നമ്മളിപ്പോൾ തുടങ്ങും, ടാങ്കറിൽ വെള്ളം അടിക്കാൻ തുടങ്ങും. അപ്പോൾ അങ്ങനത്തെ അവസ്ഥയാണ്. എന്തായാലും നല്ല രീതിയിൽ മൂവ്മെൻ്റ് ഉണ്ട്, ഒരു മാറ്റമുണ്ട്. അത് കുറച്ചുകൂടി ജനങ്ങളിലേക്ക് വരും. ഈ പ്രത്യേകിച്ചും നമ്മൾ ഊരാളങ്ങളിലൊക്കെ നല്ല രീതിയിലാണ് അവർ ചെയ്തു വരുന്നത്. അതുകൊണ്ട് ഞാനും എൻ്റെ ഒരു ലീവ് എടുത്തുകൊണ്ടാണ് ഈ പരിപാടി പങ്കെടുക്കുന്നതിന് ഇൻട്രസ്റ്റഡ് ആണ്. കാരണം അങ്ങനത്തെ ഒരു കാര്യമാണ്. വെരി ഗുഡ്. ഊരാളങ്ങളിലും എൻ്റെ എല്ലാവിധ ആശംസകളും നേരുന്നതിൻ്റെ എല്ലാ നേതൃത്വത്തിനും സംഘാടകർക്കും താങ്ക് യു, സർ.
താങ്ക് യു. That's an excellent question. In fact, I think it is already there. The natural wetlands are already there. Yes, yes. The problem is, like what sir told, because of the developments, our conventional natural wetlands got spoiled. In fact, constructed wetland is it's an excellent solution. That's what. So there has to be it's all connected problems. Like sir has told about what to do with the dredged material. Now the same is the case with soil-like materials. So there need to be a proper understanding of the material and where this is going to be used. So the problem of auction is not going to be there. So we need to be prepared maybe 5 years, 10 years before. And constructed wetland is a very important application these days, even for industrial water management, because before throwing it into the river or these waste flow into the river, we need to make sure that it is of a specific quality, which is not happening these days. So constructed wetland is a very important aspect for doing that. People are doing it for acid mine drainage, for reviving it's used. But in Kerala, yeah, and it's not a very popular concept in India even. It has just been used.
Thank you, sir.
Okay, thank you all for your patient listening.
Thank you, sir. Thank you for sharing your valuable knowledge on geo-environmental engineering and sustainability. Thank you all for all the queries. And I know I'm standing between you and lunch, so definitely we will go for a lunch break now. And after lunch break, we will have a technical session on 3D printing, the present and future by Dr. Rahul A.V. at 2:15 p.m. So I humbly request all to please assemble back at 2:15. Thank you.
So good afternoon to all of you, and thank you for having me in this tech series. So as concrete 3D printing technology, I'll give an introduction about this technology, how this is used currently, and what it holds in the future for the construction industry. So what type of projects you can really use this technology. And also if you have to use this technology, 3D printing is one among them. So what are these various techniques? Why concrete 3D printing is being looked upon as the most promising technology among the others. Then not without going too much into the technical intricacies, just a brief description about how do you design mixtures for these kind of applications. So material requirements. Then often when you deal with 3D printing, so people often say, okay, you can 3D print concrete, but then what about the steel? So how do you do reinforced concrete structures? So again, when you look at conventional structures and how do you reinforce these conventional structures, those strategies may not be directly adaptable to technique like concrete 3D printing. So what type of techniques you use for introducing reinforcement, that I cover as another section. Then as Professor Manu as well as the other speakers who spoke in the morning, a lot of emphasis in construction now is about sustainability. So when you bring in something new, a new technology, new method of construction, so what this offers in terms of sustainability, how do you really use this technology so you can have real sustainable construction, that I'll touch upon in the next section. Then I'll briefly summarize what we covered in this. So beginning with the introduction. Now, digital or let's say additive manufacturing, it's not just to construction, it's been used significantly in mechanical engineering, polymer 3D printing. So the primary difference is additive manufacturing involves a layer-wise deposition, to get the exact shape you want. And contrary to this, as you can see, there's subtractive manufacturing. So you start with a large rectangular block, then you subtract out the shape that you want. Now, this obviously involves wastage because you start with a larger volume and then you subtract it out to get your actual shape that you want. But contrary to this, in additive manufacturing, you work with precise volume. So there's much less material wastage when you do additive manufacturing. And also, if you look at how industry is proceeding in general, there's a lot of emphasis on digital fabrication techniques. Construction has been lagging behind compared to the other industries. Now construction is slowly picking up. In fact, if the economics to your robot or machine that you want to make this object, then that moves in a particular pattern to make the physical object. And then there could be some post-processing. Let's say some curing if it's concrete. Some post-processing would be required once you finally make the structure. Now, yeah, now if you look at additive manufacturing specific to construction, I've just listed out some of the common, some of the ones which has come up now. One is the extrusion-based concrete 3D printing, which I'll talk about. Then there's a technique called binder jetting. So how that differs from this and what is the advantage, we'll talk about that. And then there's also shotcrete-based 3D printing, which is also becoming quite popular nowadays. And now all these techniques, if you see, what are the advantages you get by doing this? One is quite obvious because you don't have that much labor and time. There's less labor required and you can do it a lot faster as compared to conventional techniques. That's obviously one advantage. Now, there's also the other advantage of formwork free. Now, certain construction projects, formwork can contribute significantly to the cost. So again, when you use a technique like this, significant reduction in formwork is there, and that also gives ability to, that also leads to cost reduction. Now, the other advantage with the formwork free is also, now many of the time the designer is restricted because of the fact that you have to cast it in a mold. So when you specify, when the structural designer gives a particular shape for a section, he also has to think about, okay, can you construct this shape with proper compaction or with proper embedment of reinforcement in the actual site. This then is a worry often, so you often is limited to very rectilinear shapes. Now with 3D printing, because you are formwork free, you have the possibility to, you have more flexibility for the designer, so he can look at more optimization options by shape up through modification of the shape. This also gives that flexibility to the architect. So now we'll just look at some of these basic techniques that is in use now. So one, as I've been telling you, is the extrusion-based 3D printing. So here, if you see, a structural element is made by a layer-wise deposition of concrete. So you can see that here, you have one layer of concrete put, and then the printer moves up, and then it deposits another layer. And so the one thing you have to notice is the depositing concrete has some certain special property, so it should be able to retain its shape. And then the element to be made, how it should move, that has to be pre-decided, and it's based on the virtual model that you've inputted into the machine. The other thing also you can notice with the shape on the left bottom. So that shape, if you have to do with the conventional construction, it's again quite difficult to do, but here you have that shape freed up. You can have really complex elements made through this technique. So this technique of depositing specialized concrete and then extruding it through a nozzle. This is the most common among all the techniques that we have seen. And this will be the main emphasis of the talk that I'll do. But I'll just also briefly touch upon some of the other techniques. The other technique which has also been in use a little bit is called binder jetting. In binder jetting, you have a layer of soil actually, or filler material, and then a binder is injected selectively at a certain location. So once the binder is injected, then this rolls in to put more soil on top, and then this keeps on continuing. And finally, once the entire object is made, the soil is removed and the object that you made comes out. Now this has been used in some places. If you see here, this is a work done by a UK company called D-Shape. This is quite suitable to make architectural elements. But if you compare it with extrusion-based 3D printing, you can't get the same structural and especially structural strength that you get with extrusion-based 3D printing with this binder jetting technology, because this, when you selectively deposit, it's very difficult to get that same level of compressive strength that you can achieve with conventional concrete. But the advantage is you can do more complex shapes. For example, this complexity is difficult to handle in extrusion-based 3D printing, but this can be done in binder jetting. as compared to that. So here on the other one, you're just depositing, and you can sometimes result in cold joints. But in extrusion, when in shotcrete, because you spray it at a very high speed, it sticks to the surface, so you get much higher bond. I mean, you prevent cold strength to a cold joint to a larger extent. But the disadvantage is the shape. I mean, the finish that you get with extrusion base. You get very good finish, but it's very difficult to have this with shotcrete based. This you can also see it in this image here. So here you can see an overhang being done because the concrete is pushed at a high speed and it sticks to the reinforcement that was put in place. That is being done there also, but you can clearly see that it's not really looking with a very smooth finish as you see with extrusion based. That's the advantage. When we see all the techniques, binder jetting, okay, you can do architectural elements, but very difficult to get strengths, concrete with strengths that meet conventional concrete. Here you don't get the shape or the smooth surface finish that you get with conventional concrete. So although various techniques has come, none of these techniques really popularized as much as the extrusion based 3D printing. There's a couple of other techniques also which is very rarely less used. One in ETH Zurich you can see here. This is based on very quite similar to slip forming, and here a robot is fabricating a mesh, and then that is acting as the formwork. So inside which the concrete will be placed, and then the outer will be finished with shotcrete. Just to also give you a perspective of how it's seen around the world, some major projects that's done. Now this is again only with extrusion 3D printing. So the first one that you see on the left, that is done by the US Army Corp. Their primary have concreting done more easily in inaccessible areas. Otherwise you have to mobilize your equipments there, you have to bring laborers there and have the construction done. Instead, with very limited resources, you can have barrack buildings. You can have these curved and nice architectural shape for houses and structures. Try this, and this project was set up in Netherlands. The third one is again, this is a compression only bridge. That was, so how this was made is about 100 elements were 3D printed in a factory, and this was moved in, and then it was assembled here. This was made in Italy. But this again shows the shape freedom that you, in India, if you see projects done in India, the IIT Madras students who started this company, Twasta, they have done quite a lot of work. And also the work done at IIT Madras, which is again headed by Professor Manu. They have also done significant work. I mean, if you see, majority of the push from 3D printing has been from the work in IIT Madras. So I think you would have mostly seen this in news articles, this house that was made in IIT Madras. And now IIT Madras, I think, is also doing a few other projects within the campus also, guest house buildings. Also, they are trying in collaboration with this startup company, Twasta. We in our campus also have been trying to do a few projects. We've done a recently we are doing a best stop with 3D printing, and we are also in plan of doing a few other projects during our campus. They utilize that benefit to come up with a structure like this. This was made in a few panels, and it was assembled in the Godrej site. And the best stop that we are doing in IIT Tirupati also is based on a similar concept. So with this background, I'll just give you some technical aspects also related to how do you design concrete mix for this application. So in 3D printing, if you consider any 3D printing, whether if not just concrete, if you even look at polymer, it's all based on having a liquid to solid transition. So you should have a liquid-like material initially, so you can pump it to the location of the nozzle. And then once it's exiting from the nozzle, there should be a transition to a solid-like state. In polymer, they do it by controlling the temperature. So inside the pump, it's melted. And then once it's deposited, a sudden solidification happens because of the change in temperature. But in concrete, we use a different strategy. We design concretes. So in, the strategy that we use is the flow behavior of concrete itself is quite different as compared to simple fluids like water or any other Newtonian fluid. So we work on that to design concrete mixtures. That time, then we use specialized pumps that can be used to pump this concrete up to the nozzle. I'll come to this in the next slide. In terminology wise, if you see, the ability of concrete to be pumped up to the nozzle and then further extruded through the nozzle, this we call it as extrudability. The property of concrete to extrude through the nozzle, we call this as extrudability. And the ability of concrete to retain its shape after extrusion, this we call as buildability in 3D printing terminology. If you see how concrete behaves as a fluid, this you can see it in this graph here. So the blue line here represents how a general fluid would behave. The red line is how a concrete, a fluid like concrete will behave. The difference is that the flow of concrete occurs once an initial stress is surpassed, and that a concrete mix that have relatively low viscosity. So you can, with the low viscosity, the pumping becomes a lot easier. So if you, just to give you a comparison, if you look at conventional concrete, the yield stress value will be something close to 200 Pascal. But with printed concrete, it will be more in the range of 1500 to 2000 Pascal. So there's an order of magnitude difference here. So getting that high yield stress gives that clay-like consistency and ability to retain its shape. Now this is before extrusion. Now after extrusion, we have to look at what causes failure in the concrete. So once you have a layer printed, will the layer remain stable, or what type of failures can happen in this layer, in the fresh state I'm saying. So here, if you look at, you can have collapse happening because of the plastic flow that happens in the concrete. So there's too much load on the bottom layer concrete here, and flow is initiated in this concrete, leading to its failure. This we call as plastic collapse. Now there's another interesting category of failure, that this is just like your hardened concrete, buckling collapse can happen. So especially when you do thin members, there can be lateral instability which can cause failure in the structure. And in fact, if you see 3D printing, the idea is also to do thin elements. So this is quite common type of failure, and sometimes you see combination of both also. Unlike the previous one, where it will be more related to its strength, this will be more related to the elastic modulus. If you look at strength of materials, the buckling is often related to the elastic material property that controls buckling will be elastic modulus. So both elastic modulus and the strength and how it grows with respect to time, because initially you will have a compressive strength value for the fresh concrete, and then this slowly starts increasing as cement starts to react with water. So how it evolves with respect to time is one factor that will dictate how failure can happen or what rate you can print. So just to give you a background how this can be tested. So one way you can assess these properties is by actually testing its compressive strength itself. So this study we did at IIT Madras. So here you can see this is a fresh concrete. So concrete that is at time t equal to 0, concrete that's made and immediately demolded. Then we used very low load cell to measure its stress strain curve, and then you can see what maximum values you can reach from the stress strain curve that defines the compressive strength. And this you can do it with respect to different time duration. So you make the specimen, test it immediately, you get a graph. Then you wait for 60 minutes, you get another graph. So this then can be used to create an evolution of strength, how quickly the strength is evolving. And the slope of the graph can be used to assess how the elastic modulus is evolving with respect to time. And these properties we can then use to assess how quickly you can print or how slowly you can print. Yeah, this is again in line with what we discussed. Now, there's also, in 3D printing, there's also a concept, because if you see the material requirement, before extrusion, you want the material to be as flowable as you can, as workable as you can. But after deposition, you want it to be as less workable as you can. It should be as stiff as possible. So there's a competing material requirement, conflicting material requirement. Before extrusion, you want a very workable concrete with high workability retention, very fast. So this is also quite researched upon. So this is one of the concepts that I'm showing here. So you have this structure being made, and you can see that there are two pumps connected to this. So the one pump which is depositing a very workable concrete, and then another addition coming from the nozzle. Here it's that the additive that is modifying is mixed with limestone, because the additive will not react with limestone. It will only react with cement. And then that is introduced at the nozzle, where it combines with the cement, and that causes it to set very quickly. In fact, you can, this is one, there's a way you can work with that. That is, you make small elements, then you assemble them together, and then work in that manner. Or you want to do it in an entire go, then you have to look at one of these approaches. You have to have an additive introduced. And that additive, you have to work, there again, a lot of research component comes in. So what additive you use? How do you time that setting? So the dosage of the additive that you're introducing. And then then we play around with that to get to the required height that we want. Now, this is with the early age requirements. So when you design mixes, what you should look for. Now, often as I was saying, with 3D printing, one important aspect is, okay, you make it in the fresh state. Now, once it hardens, how do you incorporate reinforcement? So with regard to that, I'll show you some strategy that's commonly used. But before we go into that, just some basic understanding on the mechanical behavior itself of printed concrete. If you look at compression behavior, now it's from the image, it's very clear because you have these cold joints that is going to modify the compression behavior. Now because of these cold joints, you can have a situation of even compressive strength being different when you test it in different directions. So when you test a cube, which is cut out from a printed structure like this, and like this you might get different strength values. So this you can understand if you look at even how generally cube fails. When you test cubes, there's a tendency for material to bulge out due to the Poisson effect. So if you have a cold joint existing, it's more easier for it to bulge out now. So that that may lead to a premature failure, say as compared to this case. So you get different strength and you also get a strength reduction. So this has to be accounted in design. Some strength reduction has to be accounted in design. The same would also appear in flexure. If you take beams in different direction and test, you will get different type. I mean, you may get different flexural strength values. Say, for example, when you test here, maximum bending stress is occurring within the bulk. But if you test it like this, where a cold joint is existing, right across where maximum tensile stress is happening, bending tensile stress is happening, you might get much significant reduction in flexural strengths. So these factors has to be also taken into account. Now, when you look at strategies for reinforcement, so the first thought was, why don't we send something like a steel cable through the through inside the concrete itself? Now, there are certain advantages to this because it goes directly with the concrete. Now, there's also problems with this. Problem is, so you have this thing attached to the nozzle that will modify your shape freedom. The whole idea of doing 3D printing is to do complex shapes. And so you are often restricted by the fact that you have this attached to the nozzle. The second aspect also is, now if you go back to how flexural strength is also, if you see, the main problem is if this is much lower, you need reinforcement in this direction. Now that you can't address like this. This will only provide reinforcement in one direction. The other direction, this will not address that issue actually. There have been few other approaches also of embedding nails like this, or even incorporating meshes. So here in meshes also, a part of the mesh extrudes out, and then the remaining, the one that comes up, the next layer embeds into that previous mesh. So this sort of establishes a connection. But here again, yeah, that's the disadvantage. So this will hinder the movement. And also to get the same area of steel that you would have with conventional steel, that will be quite difficult with nails or even this sort of systems. Now there's few other approaches. One is doing post reinforcing. So by post reinforcing is you don't care about reinforcement initially, you print the structure. Then you post process it to introduce a reinforcement. So one example you can see here is, so this is made in the form of a truss, and all tension members are externally reinforced. So steel is provided externally, and this external reinforcement is taking care of the tension. The most common, if you see actual 3D printed structures being made, especially bridges, the most common is you post tension it. So you make various elements and then you post tension and assemble. Now this is two advantages. It also ensures that it's connecting. The elements are connected together. Otherwise you have to introduce wet connections if you're, let's say, connecting through grout. When you do it this way, it compresses all the elements together and it allows you to connect. And at the same time, it takes care of the tensile, the fact that otherwise concrete can have tensile stresses. Now one concept of this you can see here. So this beam that you hear is also post tension, but now I wanted to stress is with 3D printing there's a lot more possibility for structural engineers. Now by structural engineers what I mean is you can make more complex shapes. The advantage of complex shape is with complex shape you can achieve the same load carrying capacity with much reduced material volume. If you see this beam here, if you further optimize it, there are programs which structural engineers can use that can optimize this. A significant volume reduction can be made. So a significant material volume is reduced, and therefore a lot of cement itself that you're going to use is being reduced. But then this will lead to a complex shape like this. This you can't do with conventional construction, but you can do it with 3D printing. This is done for a simply supported beam. Same thing can be combined with post tensioning. That was used in the construction of this bridge you see here. Now the other obvious is you choose a structure and again use that shape freedom to go with compression only structures. So if you look at a dome that's 3D printed here, or even the Nubian vault that you see here, they are all compression-only structures. So you don't then bother about reinforcement. You use 3D printing for aspects like this, where you try to have compression-only structures and you don't then have to worry about reinforcement. Yeah, so with this now we looked at the material requirements, some strategies for reinforcement. Now some of the earlier strategies that was proposed as issues, but post-tensioning, this is one way you can look at, one way of looking at it. With all this now we look at, okay, where can we use this in a sustainable, is this really sustainable using 3D printing? Or what type of projects where you can really apply 3D printing? Now, when you talk of sustainability, or when you talk of construction in general, you have a material. Now, there is sustainability from that angle you can look at. Then there's certain functions that your structure should serve for. Now, when you say function, let's say the building has to perform its function for a period of the lifespan it's designed. So is it able to do that with minimal energy consumption during that lifespan? So that comes in picture here. And then the shape that you use. So through optimization, like I said, you can have reduced material volume being made, the shape, and the process itself, like say formwork. So all of this are interrelated if you look at construction. So let's say if you choose conventional construction, you can't work too much with shape because you're restricted because of that. Now, because you have it in a particular shape, you're often restricted with the other elements also. So this is quite interrelated. Now in 3D printing, one is obvious that you can work with shape and cause this reduction. Process, you can utilize formwork. In function also you have this possibility because later on I'll show you that functions like thermal performance. There are studies that show 3D printed elements with the hollow printing, as we'll see in the coming slides. Now the material unit cost can be quite high. Now, as I was saying, where you apply 3D printing. So really 3D printing has to be looked at in places where you can introduce significant complexity. So this is a graph that shows the complexity with the unit cost or the cost that you would end up for the construction, and also the market value for the structure that you have. So if you have fairly simple rectilinear structure, it's very difficult to justify digital fabrication because cost will be quite high. But on the other hand, if you are increasing the complexity, there's more market value also. And with the increased complexity, there'll be a break-even point, as you can see here, where the tipping happens between conventional and 3D printed structure. Now, from research point of view, the idea is that can we bring down this further down? Especially if you see, let's say, the set on demand that I showed earlier, where you introduce an accelerator. Now, for getting that level of fast setting, you have to introduce quite high amount of accelerator. So the cost of accelerator, if you consider, then it becomes quite difficult really. So we need to look at options now where we can manufacture cost-effective accelerators. We need to understand how it interacts with cementitious systems. And all the other issues also, the binder content in itself is very high in 3D printed structure. So can we achieve that same material performance with reduced binder content? There's a lot of push for this, a lot of research worldwide. Getting this rheological requirements that you need with reduced binder content, also the specialized admixture that we use because previously if you see accelerator is required for achieving fast set, let's say, but this in conventional construction we do it through different routes. Let's say steam curing, where we use high temperature to do it. There's less push to use accelerator to do it. Now with this, there's a real drive now. So we need to look at more cost-effective accelerators. When if you are going to go with set-on-demand type construction, if you're looking with conventional 3D printing, then definitely we need to look at how we can achieve this with reduced binder content, because binder content is quite high with 3D printing. So what type of research we can do? And this has to work along with the pumping system, because the specialized pumps are used in 3D printing. So the components of the pump, with an understanding of that, both players have to work together in designing a pumping system that's capable of working with lower binder content mixture, as well as from a material research point of view also, bringing down the cement content but achieving the same rheological characteristics. So if that happens, if this further comes down, then you can see tipping point will happen a lot earlier. So even for relatively less complex structure, we can use 3D printing more cost effectively. This is the functionality I was talking about. If you look at thermal performance wise also, is again more, you may end up saying this is more sustainable, but when you look at your AC cost or the lifespan of the building, how much energy you're using to keep the home's temperature relatively in a habitable level, then if you do the calculations, this may be more sustainable actually. So here you can see that there's a comparison with some of the normally used materials and printed sections, and they perform quite well with related to the conventionally used sections. And the other option also is with 3D printing, there's also an option to do functionally graded elements. So in specific areas of the building where you need, let's say, less stronger concrete, then you can use that. But as the printer goes along, and where you need where there's high stress demand, you can use a concrete with, let's say, higher cement content in that region. So this is functional grading. That possibility is also there with 3D printing. So just to summarize the overall presentation, there are various digital fabrication techniques, and this is looked upon quite keenly by the construction industry. But if you look at all these techniques, the real one that's the most promising or the most sought after is the extrusion-based 3D printing worldwide. But to really use this technology, it's a lot about understanding the early age requirement, early age material requirement before deposition, how to pump this mixture. After deposition, how do you prevent it fail very quickly, or if you need an interaction of an accelerator, that becomes an important component. Related to that itself, as I was saying, set on demand is one of the new type of mixes that we are looking at here. Reinforcement system, there are few approaches, but now we need a reinforcement system that provides reinforcement in both directions and also provides enough ductility in both directions. Certain strategies might provide along one direction, but it has to be in all directions because that's one aspect. Then as I was saying, there's more possibility for structural engineers for optimization. So this is where that sustainability angle can come, optimizing the structure. And here there's also, as I was saying, a lot of requirement for research of bringing down the binder content. That's also a key aspect we need to look at.
Thank you, sir. Now, to the audience, please share your queries.
Hello. Yeah.
What could be the cost savings or what?
Material requirement.
Yeah.
What about the material? I mean, can you give a typical example of a mix?
I'm sorry, I don't have the mix design table here.
Yeah, you can
but,
tell me.
Approximately, you will need a binder content of around 700 kilo. If let's say we are looking at M60 grade, you will need about 600 to 700 kilogram binder. Then we can't have coarse aggregates, so we'll be around 1000 kilogram, 1100, 200 around fine aggregates. Then the remaining will be water, about 200, 230 kilogram.
So when you say fine aggregate, crushed sand is okay, locally available crushed sand, or
yeah.
do you have a specification?
Yeah, so if you look at the initial pumps that were used earlier, those pumps, actually the challenge here is, if you look at concrete pumping, we normally use double piston pumps, which creates reciprocating motion. So these ones require specialized pumps. The first generation of pumps that came, they had a very narrow section through which this material has to pass, so we were restricted to 2 mm size. But now I've seen screw pumps that can do much better, so you can have up to 4 to 5 mm size fine aggregates. Actually,
so
even with pumps that can even go up to 10 mm size aggregates have also come up now. So there's more development that's happening in that area actually.
So there is no
yeah,
impact of shape of the coarse sand?
Yeah, if you go with very high content of coarse aggregate, with fine you can still get relatively good surface finish.
Yeah, one more question. Is there any relevant codes available?
No, there's no. Actually, Professor Manu is heading a BAS committee on this. I'm also part of that committee, so maybe he may be able to give more.
Which one is that called? The committee. Yeah? Yeah, but you name it before. I mean, you will have a name, right? The committee. The committee is having a number.
Yeah, 50 CD 30.
One more question about shotcrete based extrusion. I saw a lot of wastage over there?
Yeah, there are certain places where they use it, but in my opinion, it's just looking good in a research paper. More futuristic is extrusion based. I mean, where you can really adopt to industry.
You will be sharing the presentation, or?
Yeah, I can share, no problem, sir.
Okay, thank you.
Whether this method can be applicable for multi-story building?
No. So if you're looking to build it in panels, you can. So you make several panels. And these panels itself you can optimize for different various things like thermal, like that. And then you can assemble them and use it. That way you can, but not as a whole, because then the printer becomes very expensive to make printers like that. Yeah. But this, especially in certain multi-story projects where formwork is the driving factor, there this can still be applied actually. But generally, if you're looking at simple rectilinear shapes, there are other better ways to do it maybe, not 3D printing. Yeah.
Okay.
I just wanted to add, I mean, as Dr. Rahul was saying, if for conventional structures, which are rectangular and rectilinear, and you want to go multi-story, you have much better options like precast. Precast volumetric also is there today. So all those are much faster and much more efficient. 3D printing will really work when you have to do individual customization of mass housing. Let's say you have to build 100 houses, 100, 200 houses, and each house needs to be customized. You can't do that in regular construction. This you can do, because all it needs is to create the 3D model, that's all.
Concrete, because the interlayer, like Sir was doing in his presentation, the transport of ions is an important aspect when you look at durability. So we don't have enough literature on that yet, or studies on that yet. Let's say in terms of chloride transport or carbon dioxide transport, how much it would differ if it goes through the interlayer. Some studies have shown that transport is definitely faster with especially water permeability and things like that. So right now there's not enough data, but something definitely that has to be looked upon, has to be studied definitely. Yeah, so I mean that this is the case with any new technology. Initially, they won't be, the things that you require to execute this, that may not be available in plentiful. Once only when this starts coming up, more and more of this will come. So there'll be that technological barrier when you bring in that new technology. That will be there initially. For us, so we were mostly taking from Sikka and also from BASF. Yeah, in Ghent. But it's more or less with related to the, I mean, with any, whether it's Sikka or BASF, they're supplying, say, aluminum sulfate, you can still get, I mean, you may need some tweaking, but depends on the yeah. But like I was showing, you can do external reinforcement or post tensioning. That is one way to go around it.
Thank you, sir. Thank you, Rahul, sir. That was such a innovative ideas, and thank you for sharing your valuable knowledge.
Thanks
Thank
again
you,
for
sir.
inviting me for this tech talk. Thank you.
Now, may I invite Dr. A.V. Thomas, former director, Adani
Talk was by Professor Saji, and he was talking about the massive growth requirement for the country. Almost he is telling that you need a sustained 12% growth for meeting the infrastructure requirement. That too, the procurement process and the productivity should be optimized. Okay, that was his main contention. Followed by Pandey sir, he was narrating on the national highway development, which was happening during the last 30 years, and how models got changed from simple BOT to BOT to annuity to hybrid annuity model and all. and he was talking about 37 kilometer per day construction speed with a term which he was coining permanent pavement. Okay, so permanent pavement, if you want, with low life cycle costing, then the sustainability issue is the main concern. Okay, so with that requirement, all the technical talks followed were very relevant. Okay, let me. The first talk was by Professor Manu. He was talking on the performance-based concrete construction, and he started his speech with the conventional durability design aspects, and then talking about the system where material and processes and the environment involved in the durability aspects. And he discussed about two issues, one prescriptive approach and the performance-based approach. Also narrated the challenges for performance-based specification, mainly the deep understanding of the deterioration mechanism and the transport mechanism, and also identifying the durability parameters and test parameters, basically indices, and assessment of these parameters. Okay, then he discussed about the advantages of performance-based concrete construction. One issue which he discussed was the material complexity and restrictions for adding the additives into the system, where he was emphasizing on Portland Pozzolana cement or any other blended cement, which will have much better performance capabilities compared to OPC cement. Okay, then direct measurement of the performance is possible if you go for performance-based system. Then better risk allocation is also. But he also talked about the disadvantages. Non-agreement could be one potential problem, and also at the time of failure, how to deal with it. Okay, this was, and he briefly touched upon the developments which happened in the area of concrete performance durability, especially ICI handbook on concrete durability and IS 450cc modification on performance design. Followed by Manu's talk, Dr. Sandeep also talked in detail about the role of geo-environmental engineering towards sustainability. He started his discussion with a fair narration of soil-atmospheric interaction, where drought, extreme weather, sea level rising, global warming, wildfire, etc., leading to temperature increase of the soil, resulting to hydrophobic nature, soil moisture loss, erosion, nutrient loss, increase in salinity, waste pollution, waste pollutant contamination through leaching, etc. and etc. And he discussed on the sustainability, because sustainability is a word which is used in different contexts, and he boiled down his discussion to sustainability for engineers. Okay, he was talking about creating resilient infrastructure. The ultimate goal is to create resilient. These actions are basically revolving around 17 sustainable development goals prescribed by the UN. Okay, then he briefly touched upon the future direction for sustainability in geotechnology, with special mention to Kerala environment. And the last talk, Dr. Rahul talked about 3D printing in construction, basically the additive manufacturing methodology for digital construction, covering extrusion-based 3D printer, binder jetting, shotcrete-based 3D printing, and mesh mold casting, etc. He also talked about the material requirement, special material requirement for 3D printing construction, such as extrudability, how to bring extrudability, buildability, buckling failure resistance, set on demand requirement, etc. And also he discussed on the reinforcement strategies required, because
3D printing, that's a contentious issue, how to introduce reinforcement into the system. He talked about, and towards the end, he talked about how 3D printing will be possible for sustainability point of view. Mainly, he was talking about the structural optimization and volume reduction as one point. And second one is you can have non-reinforced compression structures where tension cracks will be less, leading to better durability. And third, he said about the formwork avoidance. And fourth one was improved functionality, including the thermal conductivity, etc. Okay, so all the technical talks were revolving around sustainability and how to achieve sustainability for infrastructure. Thank you.
Thank you, sir. For your information, participant certificate will be shared through the email ID given during the time of registration. Now, may I request Mr. Freddy Soman, GM MatterLab, to deliver the vote of thanks.
A very good afternoon to you all. It has been such a honor for me to be with you today. Express our vote of thanks on this special occasion. Firstly, our gratitude, our wholehearted gratitude to Sri R.K. Pandey sir, who is member projects NHA, for accepting our invitation and for inaugurating the function and for the inaugural address, which was very informative and giving light to various aspects of NHA operations and NHA projects. And also, I like to convey my deep regards and hearty thanks to Dr. Saji sir. My hearty thanks to Dr. Saji sir for being with us today, who is Vice Chancellor, Digital University Kerala, for being with us today, and also for the presidential address, which was really crispy and was very informative and was inspiring too. And also my thanks to Thomas sir for the precisely summarizing and concluding the sessions. And also, I'm sure you will all join me in that words are not enough to express my thanks to the very valuable and eminent speakers today. Dr. Manasundhanam sir is Professor IIT Madras, Professor Sridip sir, Professor IIT Guwahati, and Dr. Rahul sir, Professor IIT Tirupati, for such a wonderful speech, wonderful topics, and wonderful presentations. Also, I would like to thank you all, the respected delegates out here, for your valuable presence and participation. I like to thank our Honorable Chairman Dameshan Paleri sir for his supports, guidance, and for his presence today. And also, I like to thank all our directors, managing director, directors, and all senior management for they're standing by us and also giving us all the motivations. And also, last but not the least, I like to thank you, all the staffs of ULCCS, MatterLab, and UL Cyber Park, for their tremendous efforts and supports for organizing such a wonderful section today. And also, before, once again, thank you all. And also, sorry, I forgot those who are unable to join today. Maybe many are watching this section remotely. I extend my thanks to them as well. And also, once again, thank you all for making this session very successful. I hope that you all enjoyed the session and it is very informative to you. And I think you all have a lot of takeaways from this session. And also, before stopping that, thank you very much. And also, there's tea arranger there, tea break is there after that one. And also, I welcome you all to MatterLab after this session. There's a tour scheduled and arranged. Buses are arranged. Those who have vehicle, you can come your own. Otherwise, buses are arranged. I welcome you all to MatterLab. Thank you very much.
Thank you, sir. Before going for a tea break, we will have a group photo session at the lobby. And as sir mentioned, after tea break, we shall go for a lab tour to MatterLab. Transportation to MatterLab is arranged and also back to Cyberpark. If you are using your own vehicle, special parking arrangements are arranged at MatterLab. So once again, thank you all for all your cooperation and looking forward for your continuous support in future as well. Thank you all. Thank you for coming. For using own vehicle, location to MatterLab in the form of QR code is available in the brochure provided in the kit. Thank you.